So we are going to start with the MySQL administration. So in your introduction class, we have seen the history about MySQL, like what is MySQL, like how it was derived, and what is the version right now going on. So as I told you, the current version in MySQL is 8, but the version right now running is 5 from 5.5 to 5.6 and running is 5 from 5.5. So in your classes to 5.6 and running is 5 from 5.5. In your classes of 5.6 and running is 5 from 5.5. In your classes of 5.6 and running is 5 from 5.5. In your classes of 5.6 and running is 5 from 5.5. In your classes of 5.6 and running is 5 from 5.5. In your classes of 5.6 and running is 5 from 5.5. In your classes of 5.6 right now, that's one network classes so now no further storage, one network folder classes for announcing the storage, one network folder classes for announcing the storage, one network folder classes for version right now running. Is 5 from 5. And in this right side, you will find an DVD image. Click on that and go to the location where you have actually go and downloaded your Linux DVD. An ISO image basically you need to get. So we are working with Red Hat Linux, so you can go and have your Red Hat Linux. Different versions are available in Red Hat Linux, like right now in Red Hat Linux, like right now in Red Hat Linux, like right now in whatever the version you want, you can choose. Basically, I'm going with 5.5 here because 5.5, most of the RPMs are inbuilt. You don't need to go and have your yum, or you don't need to go and do a lot of settings in 5.5. So basically, we are not going to deal with your RHEL administration here, right? I just wanted to have a plain server where my Linux is available, and our main focus is to just go and install your MySQL and work on MySQL, right? So that's why I've chosen a version that is more inbuilt and a lot of packages, lot of tools that are already available in 5.5. Okay, so that's why I've chosen RHEL.
This conference will now be recorded.
So we are going to start with the MySQL administration. So in your introduction class, we have seen the history about MySQL, like what is MySQL, like how it was derived, and what is the version right now going on. So as I told you, the current version in MySQL is 8, but the version right now running is 5 from 5.5 to 5.6 and 5.7. Okay, so in your classes also basically we'll go with your starting with your 5.6 and 5.7 we'll learn, and later on I'll just show you what are the new features of your MySQL 8 and all. We'll see it later on, the MySQL 8 version also, because you need to have an idea on the new version also. Maybe tomorrow if you are upgrading to 8, like what are the new features of your 8 and what are the differences between your 5.7 and 8 there. Okay. So right now, today we'll be starting with your MySQL architecture. Okay, so before going with your architecture, what I'll do here, I'll try to build up the server, because for MySQL we require a server where we need to have a Linux installed. Okay, so we are going to work with the MySQL on Linux operating system. So what I'll do here right now, I'll go and create a virtual machine, and we'll install Linux in that. So Linux installation easily it will take around 20 to 25 minutes to complete. So let it go, let it complete. Meanwhile, we can come back and we'll see MySQL architecture. So with this, we are not going to waste your time in just seeing this, simply seeing the installation, right? So let me first go and okay, so I already have this virtual box installed here for me. So I'll send you the link to go and download your virtual box. It's a small exe file. If you want, you can download it from virtualbox.org also. From there also, you can just go and download the virtual box, and a very small exe file. It will just take 2 minutes to download your virtual box. Just say next, next, next. Don't give any other settings there. So my virtual box is already available. Now we need to go and create your virtual machine in this. So I've got a lot of virtual machines here. Just delete some of your virtual machines. I'll just go and delete this virtual machine there.
This conference will now be recorded.
I already have the virtual machine, but just need to know which Linux version I need to install. Yeah.
Okay.
Virtual machine, I have it already because I do use my virtual machine.
Okay. So you don't want to see the Linux installation here now?
Go ahead. That's fine.
Okay.
It won't be that long. Just quick installations. I record this. We have the recorded session, so.
Yes, yes. And that way you can see like what are the network settings you have to do, and how do you integrate your Linux server with your Windows machine so that you can go and access it.
Correct.
All these points you can see there.
And also configure the MySQL workbench and all that.
MySQL workbench we are not going to configure in your classes here. So we are going MySQL core, completely your MySQL command line only. So MySQL
command line.
Yeah.
Okay, perfect. No issue.
Okay. So now we'll go and say new here.
Yep.
You just give some name for your virtual machine, and I'm going with the Linux operating system, and that too we are going with the Red Hat Linux. So either you can go with 32 or 64-bit. I'm going with 64-bit here. Red Hat Linux. Next, just to give some memory for your server, I'm giving around 2 GB memory. That is more than enough. If you have more memory, you can give 4 GB also for one machine, because I'm actually giving 2 GB because later on I require one more MySQL server when I'm doing replication or cloning. Okay, so I require multiple servers, so I'm not giving much memory here for one server only. So 2 GB I give. Create a virtual hard disk now. And whenever we create a virtual machine, it is stored as a VDI image, virtual box disk image. These VDI images actually you can import it to some other server, and you can just build up your machine in another server also. Okay, so you can just remove these virtual machines, VDI images there. So just
Okay.
say next, and say dynamically allocated the hard disk size. Okay, so right now in the starting, I'm just giving an hard disk size of around 40 GB. That is
Okay.
more than enough for all our activities, because only we don't have much users logging in here. Only I'll be logging, and maybe 2 or 3 normal users I'll create there. So 40
Sure.
GB space will be much enough there. But if I require more space also, we can just go and increase the hard disk size, because I am choosing the dynamically allocated option there. Okay, so that's why you always choose your dynamically allocated option. And where
So
do
when
you
you have
want to store?
dynamically located, so you can increase anytime you need.
Yes, you're right. Anytime if I want to have more disk space, like 40 GB is not sufficient. I just want to have more space there. I can go and add more 20 GB there if it is dynamically allocated. If it is fixed size, we cannot add.
Got it.
Okay, so I just want to store all my VDI images, some VDI folder in my D drive. I have created a VDI folder. In that, I just try to keep centrally all my VDI images. So just keep it over here and say save, create. So now a new virtual machine is created there. Now we have to go and do the settings. It's like a virtual server, but basically you're building up a server. For a server, what are required? A server requires an IP or a host name to be pingable there. Okay, so we'll go and do the networking there. For IP are your network card that you define. So already one network adapter it is available. We'll say it is attached to host only adapter. We'll choose host only adapter, and advanced option will say promiscuous mode allow all. This is because I just want this machine pickable from here virtual machine, from your virtual box, and from your Windows also, or maybe from another server also. Maybe from a different laptop I want to go and connect to this server there. So
Okay.
remotely also you want to connect. So we have to give this promiscuous mode allow all there.
Okay.
Okay, so this is your networking. So one Ethernet adapter or network card is enabled by name some ETH0 it will be coming in. So for this Ethernet adapter or network card, you can assign in public IP, an IP address we can give there. So that we'll see later on how to assign the IP address and all. So right now, one network card is enabled. Now go for your storage, ID controller. In this, go for empty symbol. And in this right side, you'll find an DVD image. Click on that and go to the location where you have actually go and downloaded your Linux DVD. An ISO image basically you need to get. So we are working with Red Hat Linux, so you can go and have your Red Hat Linux. Different versions are available in Red Hat Linux. Like right now in Red Hat Linux, you have got 8 also. RHEL 7, 8, 6, 7, 8, 5, whatever the version you want, you can choose. Basically, I'm going with 5.5 here because 5.5, most of the RPMs are inbuilt. You don't
Okay.
need to go and have your yum, or you don't need to go and do a lot of settings in 5.5. So basically, we are not going to deal with your RHEL administration here, right? I just
Okay.
wanted to have a plain server where my Linux is available, and our main focus is to just go and install your MySQL and work on MySQL, right? So that's why I've chosen a version that is more inbuilt and a lot of packages, lot of tools that are already available in 5.5. Okay, so
So
that's why I've chosen
where
RHEL 5.5.
okay, where can I download that one from? Red Hat?
Yes, from redhat.com.
You would
From
have a
Red
link
Hat.
for that?
I'll send you the link. Otherwise, actually, sometimes if you are unable to download, you just try it out in redhat.com. You go and just try to download RHEL 5.5. If it is there, if you are able to download, that is good enough. Otherwise, I'll send you the dump to you directly to your email.
Okay. Yeah, that'd be nice.
I'll send you the dump better. Okay.
Okay.
So just click on OK, and your DVD we have attached here, because this is a difference actually when you're working with your actual server and virtual server. In actual server, we would download the software in a DVD, and directly the DVD would insert into the server and it would get mounted. But here,
Correct.
this is my virtual machine, so I have used this option, that storage. We have ID controller. We just connected the DVD storage, and now my DVD got connected to my server there. Now just go and say start, so that now my DVD will be mounted and your RHEL or Linux installation will be started. Just say enter.
Yep.
You can skip the media test because we have downloaded from a trusted site only. We have downloaded the software.
Okay.
Otherwise, the software also will be tested. Like if it is from a trusted software website, and if it is good enough, or it is having any kind of issues or corruption.
Very.
Any version you go, either you go with Linux 5, 6, 7, the installation steps will be the same. But after installation, if I want to use any kind of tool or anything, I need to go and get your YAML through internet. I have to download it in 6 to 7. Differences will be there. But
Sure.
the installation
Right.
step will be the same for any version you're going. So I'm
Right.
going with English language. Just go with your US English.
Now, do you
And it
have
is
a list?
asking,
Yep. You have a list of RPM that need required for the MySQL?
list of RPMs is not required there. When I'm doing MySQL installation, actually MySQL has an RPM installation also. There I'll show
Oh,
you what
okay.
are the RPMs required there. We can go
Okay.
and download those RPMs directly from mysql.com.
Got
So
it.
from mysql.com, we'll download those RPMs that are required for installation. So if it is
Okay.
saying that to enter your installation number, because that is given when you have a licensed RHEL. Okay,
Sure.
so we don't have
Okay.
license installation number, so you can just skip that entering installation number. So it says that if you
Okay.
cannot locate installation number, consult Red Hat, you can get that. Just say skip, it's not required. Now, do you want to
Okay.
go and create your partitions? Yes. So in Linux is basically about your partitions only, like what is your slash, root, swap, etc, boot, var. So all those partitions, suppose if a Linux administrator is doing this installation, a system administrator, he would go and choose a custom layout. Two options are available here. Either you can go for a custom layout, or you
Uh-huh.
can go for a default layout. What do you mean by custom layout? Custom layout means you have to give the sizing for all your partitions. Like
Correct.
what will be the size for slash? Like boot should be 1/4 of your RAM. Swap should be double of your RAM. Like that, every partition you have to give the sizing. So definitely, if a system admin is doing in a production server, he will give you the proper sizing for all the partitions. Okay, but here we are not going to do any custom layout, because we need to sit down and see what are the exactly what size I have to be for each and every partition and all. Instead of that, when more option is available, we can say default layout. Default layout means some random sizing will be given for all your partitions.
Got
Okay,
it.
that will be done automatically. So you're not bothered about any partition sizing. So just say default layout and say next. So it says that you have chosen to remove all your partitions and create a default layout. Are you sure you want to do this? Yes.
Yes.
And because I have enabled the network adapter, the Ethernet card, you can see the network adapter name is given as ETH0, that is Ethernet 0. Okay. So
Okay.
suppose tomorrow if I require one more network adapter, if I just go and attach an adapter there, it will be named as ETH1, ETH0, ETH1, ETH2. The names you will be getting like this. So just see that it is active on both. Yes, it is active on both. So only this thing you have to check there. And the host name. Do you want to give the host name here itself? Because every server we need to give an host name. Like using that host name, we can go and access that machine. So do you want to give it over here or later on? I'll just give it later on in your etc host file. We'll just go and edit that later on.
Okay.
So just say next. No need to give it over here. And in what time zone you are actually living in. So according to that time zone, you have to give the um, you have to select that proper time zone there. So you'll have a proper time in your server, proper date and time in your server. So
Sure.
right now I'm in India. So according to Indian time zone, it is Asia Kolkata.
Okay.
Okay, so I'll have it that time zone, date and time there.
Yep.
So next, so when we are installing, working with Linux, you'll get a root user. So for that you root user, I just need to assign the password here. So root is a super user who is actually managing your complete Linux file system and all.
Okay.
So here, because I'm working with Linux 5, I've got two options there, software development and work server. To just choose these two options to get all your required packages, all your RPMs. But if I'm going with
Okay.
Linux 6 or 7, the higher versions, you will get one option called, you'll get multiple options there. In that, you can just go and choose your desktop option. There will be one option called as desktop. Desktop will give you
Yep.
all the required necessary packages, all the graphical packages and your command line packages and all will be getting. So just choose one desktop if you're working with version above 5, either 6, 7, 8, whatever version you put.
Sure.
Just say next. And this installation, it will take minimum of 15 to 20 minutes to complete. And after this installation, you will get some post installation steps also, where you have to go and disable your firewall, disable SE Linux. Because on top of this server, I want to go and install MySQL software. I just want this software to be accessible remotely also. So if firewall is enabled, it will not allow anything to be installed there. So there are
All right.
certain post installation steps also we have to do there. So that anyway we'll do after the installation.
Sure.
It's checking for the dependencies also. Whenever we are working with Linux, it's not only about RPM packages that are mainly available. You have a lot of dependent packages also. So if dependencies are not properly installed, also your installations will fail. So just say next. So now my installation is started. So let it continue for. And whenever you want to come out of this console, in your virtual machine console, your mouse pointer will be captured. So you have to press right control on your keyboard. You can come out of this console. So let my installation continue here.
Okay.
Now we'll go with the architecture part here.
Okay.
So basically, MySQL architecture, we can relate with your Oracle architecture. You're an Oracle DBA, right?
Yes.
So you will be having an idea how your Oracle architecture works. Basically, what is your Oracle architecture? Whenever a user fires a query, that query is taken by a server process. Server process will take, in Oracle architecture, you have three parts, that is memory, storage, and your process. Okay, memory,
Yep.
storage, process structures. So memory means we have got SDN, PGN, Oracle. Like whenever your query comes in, the server process will take the query to your SDA. In SDA shade pool, the query processing will be done. A hash value, a parse code, execution plan is generated, and then the data fetching will be done. So for fetching the data, it will go and fetch the data from your storage. So your storage can be your from your table spaces, from your tables, the data will be fetched. From your data files, the data will be fetched and it will be given back to the user. And you have got a lot of background processes also in Oracle. You have got S1, P1 and all, so many checkpoint background process and all, lot of background process. So Basically, in Oracle, we have got only three types of files: data files, control, and reader. And specifically, only one type of memory component, that is SG. Any amount of queries that comes into your Oracle DBA server, you just have one fixed memory, one fixed file system. Okay, but when you work with MySQL, it is no fixed memory, no fixed file system. So it depends like what kind of data you are accessing. Your memory also will be changing there, and your file system also will be changing there. Okay, that is one thing you have to remember, and we'll see what are the changing, what are the different memory structures you are having, what are the different file systems we are having when we work later on. But right now we'll go into start with your MySQL architecture. So now you have an idea on Oracle architecture. Now, when we go with your MySQL architecture, first of all, when a client makes a request, the client request is taken by a connection manager. Your connection manager is nothing but like your server process. And one thing you have to remember, MySQL doesn't have any background processes. Your MySQL database doesn't have any background process. Like in Oracle, you have got a lot of background process, like how you are,
Yes.
like every background process has a job there, from
Right.
where it is reading the data and where it is writing the data and everything. But in MySQL, it is not such. MySQL, they just have a lot of predefined things. A lot of things are predefined, and a lot of structures are available which will actually connect, and your data will be moved from one structure to another structure. The connections are available in MySQL. Basically, connections are available, not your background processes.
Okay.
Okay. So whenever a client makes a request, that request is taken by a connection manager. Connection manager, you can imagine as your server process. Okay, that will be taking the request, and your connection manager, when it actually takes a request, it will give it to the thread manager. Your thread manager basically will create a thread for every query that is coming in. Okay, so whatever the query comes in, one thread is nothing but a process only, right? So a process or a process ID is generated for every query that comes in MySQL server. Okay, so a thread manager creates a thread, and then it will given to a user module. User module, basically the user authentication will be done. Basically, user module can come in the third place, or it can be on your first place if you are having an application, because your user authentication is basically done at your application level only. So if you have applications on top of your MySQL server, your user authentication is done at your application level only. So you no need to have any user module coming over here if you have applications. But if you don't have any application directly, your clients, very rarely happens there. But if a direct connection to your database server, MySQL database server is made, then a user module will be there, which will be authenticating the users, like he's the proper user, and does he have the proper password and all. User will be authenticated. Then the query is given to a command dispatcher. Okay, so here how the client is connecting to your server here, basically there should be some kind of networking files here, something. What kind of networking will be there between your client and server of MySQL? Like in Oracle, how the connection is made there, we have got network files there in Oracle. We have got listener on Oracle server, and a TNS service file on your client server, and using these TNS and this listener networking, you just try to ping and they get connected. But
Correct.
here in MySQL, we don't have any such kind of network files. So
Okay.
how does networking happen here? Your networking is basically only through your network port number. Okay, the network port number is very important, because basically the data is transferred over the network port only, right?
Yes.
The data packets are transferred over the port. So if you can give that network port number, that is enough. And it is using basically the TCP/IP protocol, the TCP/IP protocol for all your networking, and it does use your network port number. So what is the default network port number in MySQL? Like in Oracle, we have 1521 for Oracle. In for MySQL, it is 3306, double
Three
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 zero six.
3306 by default
Yes.
port. Okay.
Default
Got
port, yes, that is a default port. If you don't provide any network port there, So at the time of installation, your MySQL will pick up 3306 as the default, and all your networking, all your data communication will be done on that port. But if you feel that I don't want to give that default port, I want to define my own network port number.
Mm-hmm.
Okay, so you can go and define your network port number, but where should I define them? So there should be some file where can I go and keep my network port number, or any other thing I just want to, any other MySQL server related parameters or something I just want to keep there. So what do we do in Oracle? In Oracle we have got P file, right? A
P5, correct.
parameter file or SP file where all your database parameters and everything are kept there in your P file. Same way
Right.
in MySQL we have got your MySQL configuration file. In MySQL, we have got your MySQL configuration file by name my.cnf. So as the
My,
classes go on,
my,
my.cnf,
my.cnf.
cnf, yeah, my cnf, cnf is configuration. Okay, so my.cnf file is available. This is basically like your configuration file, we call it as, or we can consider it as your parameter file. So in your configuration file, all the configuration related parameters are kept. So we can go and define your port number in that configuration file.
Got it.
So I don't want to use 3306. My network admin has given me a different network port number. So whatever the network port you have, just define that network port, and over that network port only the data will be transferred. And not only the network port, tomorrow if you want to have any kind of parameter about your MySQL server, your database parameter, anything you want to keep in your file, you can have that in your MySQL configuration file. Okay,
Okay.
so where this file is located again. So this file location, there is lot of uh, what you call confusion here for about the file location there, because every version the file location is changing.
I
Like
see.
in Oracle, if you go, it is fixed. Like your P file is there in Oracle Home DBS location, right? So
Right. By
starting from
default.
your Oracle by default, that is the location. But for MySQL, every version you go, the file location is different. So if I'm working in 5.5 till 5.5, from MySQL 4 to 5.5, the default location for MySQL configuration file was etc/etc. We had this my.cnf file. Okay,
Slash
but from
etc.
5.6 onwards, yes, in /etc location you can find my.cnf till
Okay.
5.5. But if I'm going with 5.6, 5.7, the location is in USR/USR location. You can find your MySQL configuration file. It's there in your USR location.
So
Okay,
5.6 and above is under USR.
USR, yes. And earlier to 5.5, from 4 to 5.5 was there in etc location, and below that version it was in a different location. But below that version nowadays we are not working, right?
Right. Right. We'll
No
just
need to
worry about the
consider about
current and new version.
yeah. So we are just, you just need to know, like in 5.5 it is there in etc location. Why I'm saying 5.5? Because many of the companies they still have 5 also. Many of the companies
Yes.
they still are working with 5, 5.1, 5.2 also they are working. So you need to know like what is
Yes.
your configuration file location. So that's why we have to consider these things. So in your MySQL configuration file will define the network port number. Then what happens, your client makes a request, and over that network port, like maybe 3306 is the network port, over that network port the client request, that is consider like I'm just requesting the some employee information. Like I'm having an employee table, so I'm taking your employee information, select star from employee. Okay, so that query is given to your connection manager. Your connection manager will establish a connection, and it will give it to the thread manager, which will create a thread, or a process ID is generated for that particular query, and it is given to a command dispatcher. So the command dispatcher, this is one good thing. This is one thing that actually you need to understand. Your command dispatcher will actually give the query to your parser. So command dispatcher, it will dispatch the queries either to a parser stage, or it will give it to a query cache model. So what does your command dispatcher do? Okay, what happens in Oracle if the query enters for the second time? If the query is entering, what happens there?
Or if it's
Suppose,
in if it's there, they will pass it from memory, buffer cache.
yes, yes, you're right. Right. First time if the query is coming in, then it will go and fetch the data from your disk and all the processing will be done. But
Right.
second time if the query is coming in, it is called as soft parsing.
Soft
Soft parsing and hard parsing.
correct.
So second time if it is coming in, it is soft parsing and it will go and read the data from your memory. Here also in MySQL, first time the query is coming in, the command dispatcher, because the thread manager has created a thread there, it will come to know that this is your first time the query has come in. Then it will go to the parsing stage. Okay,
Okay.
but second time the query is coming in, same thread, same process ID is generated, it will not go to the parsing stage, it will directly go to the query cache model. Cache means what? Memory. Your query cache model will have the output of your query.
Okay.
Okay, again the output of your query, you know, like for how long the output will be kept there. Like in Oracle also in your buffer cache, it depends on the size of your buffer cache, and it depends upon how much of based on your LRU list again,
Uh,
least
Correct.
recently used list and all. So here also the same concept is repeated here also in query cache module, like based on your LRU list, if it has sufficient space, then you can find the output. If space is not sufficient, then maybe your output might be written back to your files there. So your command dispatcher will go and check there. If the output is available, it will read the output and it will give the output back to the query or back to the user. If not, then again the whole processing has to be done and it has to go and pick up the data from your file. Okay.
Right.
So first time the query is coming in, your command dispatcher will give it to the parser stage. One good thing about your MySQL here is when your parser is going and giving the queries, your queries are divided into multiple components here,
Okay.
multiple modules. We call it as modules here, multiple
Okay.
modules here. So what kind of modules? Like in Oracle, if I'm having a select query, insert query, a DML, DDL, or a select query, anything, all your queries will go to your FGA. All your queries will go to your shade pool. Shade pool only the query processing will be done and the output is taken, it is given back to the user. Any type of query. But here in
Correct.
MySQL, the multiple different types of queries will go to different modules. Like suppose if it's a select query, it will go to your optimizer module. Okay, so
Hmm.
your optimizer module will take your select queries, and optimizer basically it is given the name here because it is optimizing that, because mostly select queries will be what, it will be kind of read-only queries, right? You're
Correct.
not going to make any changes there. So it's, the
Correct.
name is given here like your optimizer. Don't consider this optimizer with your Oracle. In Oracle, we have optimizer to give your execution
To
plans and
tune
everything.
the performance.
But here yeah, performance. But here this optimizer is not giving any plan and all there. The module name is given here because it is optimizing the time there, because your select queries doesn't take much time there. They are read only queries. Even if
Okay.
they are coming 10 times to the server, same output will be given there. So your
Got it.
optimizer will take the query and it will give to the access control module. So your access control module, it will have the access to all the tables. It is controlling the access there. So in your access control module, basically the permissions of your user on that table are checked. Okay,
Correct.
so the permissions on the table. So many of them have a query like user module. We have already done the authentication. User
Yes.
module authentication, only the user authentication was done, like user name and his password and all. But the table privileges, which what kind of privileges he has on the table and all is checked here in your access control module. So
So
does
there
he have
only
access?
so there will be two different privileges, one for connecting to the database
Yes,
for the user and one for the accessing the data at the table
data.
level.
Yes, the privileges, the database level privileges, like
Correct.
does he have the read access? Does he
Table level.
basically have the access all or not onto the table? Maybe some users doesn't have an access to the database.
Correct.
okay, or maybe doesn't have an access to the table itself. So access control module will actually check, does he have the complete access to go and have that to go and access the table data there. So if he is having, then he'll go and connect the query is given to a table manager. Table manager is like a manager. He's completely managing all the tables there. So your table manager will go and give the query to an abstract storage engine module. Storage engine, this word is really very important in MySQL here, because
Storage
where
engine.
your data is being stored. Yeah, storage engine is basically how your data is stored and where your data is stored in your MySQL server.
Okay.
Okay,
My
so multiple storage engines are available in MySQL. You have got some 8 or 9 storage engines are available in MySQL. Okay, so how your data is being stored. Basically, you want to have your data permanently, or you just want to have your data as a read-only data, or you just want to store your data for a longer duration. So depending upon the requirement, your different storage engines are available. So the two most important storage engines are MySAM and InnoDB.
okay.
Okay,
I know the
MySAM and InnoDB. Okay, so these two are the most popular storage engines. But other than these two, you have got some 7 or 8 other engines are available. So
okay.
in your coming classes, we'll see what are the different types of storage engines, what are its features, what are the differences and all, and how to create those storage engines and all in detail. We'll see, because that is really very important when you are
Sure.
working with your MySQL file system at all. Okay,
So
so here your abstract storage engine will go and check your table is available in which storage engine.
who
Okay,
makes the
so that is
decision by
the,
storing data? Which storage engine
yes,
to use?
that is dependent upon your client. Actually, your client
Requirement?
requirement. Yes,
Okay.
your client requirement, it depends. Like your client says that I just want to have a database which is only kind of read-only environment. I don't want
Okay.
to give them any read-write access on my tables. Then just store your data in your MySAM storage engine table. Or
I
you
see.
want to have a read-write kind of environment. Like I told you in your introduction class, like MySAM, we are using Google.
All right.
Google is actually using your MySAM, MySQL engine tables there, and Facebook, Twitter, they are using this InnoDB engine tables there.
Because
Like you
you
want to
can
change
user
your
make a
data,
change.
yeah, you want to change the data, and that change has to be permanent also. It's not like you are changing the data and you're logging off the session and your changes are gone. Not like that. The
Okay.
changes have to be permanent also. So that is your InnoDB engine. Like these many engines are available, but these two are the most popular engines. So only these two engines, many of the companies, many of the
Ha,
clients and what you call projects will be using these two
got
engines
it.
only mostly. And can we have multiple engines in the same server? Or should I have only one engine
Okay.
kind of table? So multiple, both options are available. Either I can have whole database tables as my SAM. Okay, all tables to be
Okay.
read-only kind of tables. Or I can have a combination of both. Some tables my SAM, some tables InnoDB like that. Okay, but very
Oh,
rarely
you can
we'll
have
go with
both. Okay.
your
Combination.
we can have both combination engines also, but very rarely we go with your combination engines actually. So whenever we have a bigger environments, bigger databases, when we are working, we try to choose one type of engine only. So we'll
Okay.
try to go and set one engine as a default engine. So all your tables that are created, either they are MySAM read only, or they are InnoDB like that. So we try to have only one type, but it's possible that you can have a combination of your engine tables also you can have them. Okay. And so basically your table
Okay.
manager will take the request and it will give to the abstract storage engine module, which will go and check that which engine my table is being kept. Because again, but depending upon your engines, your file system is also changing there. If I'm going with
Sure.
MySAM, my tables will be stored in a different files. If I'm going with InnoDB, different files are available. I have another type of engines, like I have got archive engine, federated engine, different files are available. So your abstract engine not only going and checking the storage engine, it has to go and check your file system also. Like which file I can go and get my data. So it will go and get the data Now your abstract engine will go and suppose my data is available in your InnoDB. So it will go and get your data from your InnoDB file and it will go and give the data back to the user. But before giving the data back to the user, a copy of your output has to be kept. Maybe the query is entering for the second time, it will be easier, right? So to keep your
Right.
copy of your output for the second time, the copy of your output is kept here in your query cache. Okay, it's
Query
like a
cache
buffer.
module. Okay.
The query cache
Right.
module will have the output, so that second time if the same query is coming in, no need of going and parsing and all, and this access control module, nothing is required. Directly the query, the output is taken from your query cache module, it is given back. The output is given back to the user. Okay, that is
Okay.
for select. That is for select queries only. But what if
So,
I'm getting
right.
any DML query? What if I'm having any DML queries like updating, inserting, and all? Then it will go to your table
Right.
modification module. Your table modification module, it will go and check there that if you're making any kind of insert or update. So that your queries will go to your table modification module and then access control. Here it will be the same. So why they are differentiating
Sure.
here in this way? So just to improve your query processing speed. Okay,
Okay.
so in Oracle, what happens is like in Oracle, all your queries, all type of queries will go to your shade code, and your query processing will happen in your shade code only.
Right.
Okay, select will take faster. Select queries will be more faster when compared to your DML queries, right? So select queries will
Correct.
take less time. So here, if I am just dividing the modules here in MySQL, what they have taught it, if you can divide the modules, then your select queries will be run very fastly and your data will be fetched very fastly if it is a select query. Suppose if it was if one module was available, then it would be very difficult to differentiate your select, differentiate your DMLs and all. Okay, so that's
Okay.
why they have given different modules. And when we just compare the query processing speed with your Oracle, the MySQL query processing speed is very high. Very fastly the
Okay.
query is processed, like in microseconds, I can just say. Fraction of seconds
So,
only your
so,
MySQL queries will be processed.
so what's like if is a query been fired? What is the default or minimum time
No,
before someone
minimum
says,
I
okay,
cannot just say.
my
In on your screen you'll be just seeing zero only. Most of the time you'll see 0 seconds only on your screen.
I
But if
see.
I really want to
Okay.
go and see what exactly the time it has taken, I'll show you in
Yeah.
your performance training class. Like if I execute a query, we'll go and see what
Okay.
exactly the time it has taken. Then you can see there like in milli or microsecond time it will be showing you the exact
Got it.
query we can see.
Okay.
I'll show you that query with
Sure.
that parameters. You'll see how to exactly see your query execution time here. But when I compare with Oracle, I'm just saying that Oracle is
Right.
very
Right.
defined, but Oracle takes a lot of time to process the query. Because why it takes time? Because Oracle has background processes. One
Yes.
thing, every background process has to be invoked. Every background process will take some time to take the data from here to there and reading and all, and everything is being processed in one location only, that is in shadeful. But here we have different divided different modules, so the query processing will be done very fastly here. Okay,
Okay.
so if it's an insert statement, it will go to your table modification module, and then there, if it's a kind of any kind of repair, like any kind of corruption, like your table data might be corrupted, right? So if any kind of
Okay.
corruption query, repairing queries you are giving, then it will go to your
Mm,
table maintenance model. Okay,
I
then
see.
if you are having any kind of a replication, like suppose I just want to replicate my data, clone my data to another server. So when I'm replicating
Okay.
also, I'll give lot of commands there, so all those commands will go to your replication module. And if I want to check any kind of reports, so like we
Hmm.
can generate performance reports, we can just have plans also here, we can have your execution plans also here in MySQL database here. Like in Oracle we have got your execution plans there. Same way we can generate your plans, we can generate your reports there. So if I want to see the status of your reports, any query if I'm firing, then that will go into your status reporting mode.
Okay.
Okay. And so with this, what happens? So with the reason behind dividing this, the query processing time will be reduced here and it will be much faster. query will be much fastly executed. So this is basically an
Right, because
overview of
yeah,
your architecture.
got it.
Yeah. So in detail, we have to go and see this in detail architecture, like how many types of caches are available. Like I'm just saying it is going to your, like in Oracle, we just have buffer cache. That's all. Whatever
Right.
the output is there, that will go into your buffer cache only. But here it is not such that. So if it's an InnoDB table, it will go to your InnoDB cache. If it's a MySam table, it will go to your MySam cache will be there. If it's an another engine table, it will go into a different cache. So again, depending on your engines, your different types of caches are available. So that we have to see. And then logging module, like whatever the queries
Mhm.
that are coming in. So you should be having some logs also. Like I should be knowing that how many queries have entered to my server and for how long the queries have been processing. All the logs should be available. So yes, what kind of
Okay.
logs are available in your MySQL server? Different types of log files are available. Okay, so and where they are located, where your logs are available. Like tomorrow, if you have any error or anything, where can I go and find my error log file?
Sure.
Okay, so where can I find my error? In which log file I can go and check? Tomorrow, I just wanted to see that if my query has executed, um, so where exactly, how much time your query has taken, and who has like a kind of auditing also, like who has actually fired the query and all. So all these things I can go and check it from your log files. So what kind of log
Okay.
files are available, and what kind of how many different types of storage engines are available. So all these things in detail we have to check them. Okay, so this is basically, I can just say, an overview of your architecture for your MySQL. Like whenever a MySQL in the server, if a query files, if a query gets filed, the query comes to your MySQL server. A connection manager takes the query, and it gives to a thread manager. Then user is authenticated. Your command dispatcher dispatches the query to different modules. From there, your access control module and table manager will go and check that which table your which engine your table is present. From there the table data is picked and it is given back to the user. Okay, so much similar to your Oracle architecture
Okay.
here. It is
Yes.
much similar to your Oracle architecture, right? So any database you go, not
Yes.
only
Yes.
MySQL, tomorrow if you're going in for your SQL server also, any database, the architecture will be the same, but
Mhm.
little differences will be there, like how they are actually the query, how it is executing, and what kind of module. So if you learn that thing by comparing with your existing database, that will be much easier, right? Okay,
Got
so
it.
in detail architecture we'll see in your coming classes anyway. The remaining 8 minutes, it is saying, like 5 more minutes, your execution will be done, and you'll be getting some post installation steps there. So in post
Okay.
installation steps, what you have to do is you have to just go and disable firewall, disable SC Linux, and
Yes.
it will ask, do you want to create any other
Right.
user you want to create? Not required now. Root is the user. We can work with your root user, and that's all.
Okay.
And next class,
Okay.
tomorrow's
Got it.
class, I'll just go and try to set up your networking. Like I'll try to assign the IP to this server, host name will assign, and then we'll start your MySQL installation. Like what are the
Okay.
different types of installations available? Like in Oracle, we have got your command line, command line installation, or we can go with your DBCA installation,
Yep.
sorry, OUI installation you can do, or you can do a silent installation you can have in Oracle, right? In MySQL, we have
Right.
got a command line installation, like we can go with different types there. You have got RPM installation, you have got community installation is available. So we'll see that in your next class. Okay. So it will
Okay.
take time. I'll just stop it over here for today. You can do your post installation steps, right? As soon as this is done, you'll
Yes.
get one more screen where you have to just say next. Just disable the
Right.
firewall and
Right.
disable SC Linux. That those two are the important things. And once you do that,
Sure.
your machine is ready. So now,
Right.
right now, my server is ready. Tomorrow we can start with your MySQL installation.
Okay.
Clear?
And also, you're gonna share this presentation, right? PowerPoint presentation.
The
Yeah.
PPTs.
Yeah.
This will be there in your book.
My
The
book?
PDF material I'm saying, yeah, the
Oh,
PDF book
okay.
I'll be sharing with you. In
Oh,
that you'll
okay,
be
great.
having all these.
Oh, okay.
Okay.
So there. Perfect.
Yeah.
Okay.
So we'll
This conference will now be recorded.
Okay, so last class we have actually downloaded all the required software. So two types of installations are there in MySQL. The first is binary installation, or it is called as source code installation, and the second one is RPM installation. Okay, so in binary installation, you need to define, I told you, you need to define it from scratch, like everything you need to do it manually there, like defining the directories, defining the MySQL configuration file, and when you're connecting to the MySQL server, a utility you have to use. When you're shutting down or disconnecting, another utility you have to use. So a lot of processing and a lot of commands are involved in binary installation. So to avoid these issues and problem, many of the companies, they try to go with your RPM installation, which is much predefined there. So and RPM installations are much easier to install, and later on management is also very simple when you go with your RPM installation. Okay, but first we'll see your binary installation so that you'll have an idea like how to do your binary installation. So I think I have already copied my uh, binary installation file in stage directory. So it's a tar gunzip file, it is available. So I need to unzip this file and untar the file. So I have already shared the practical documents with you and theoretical documents with you. In this you can follow the steps there. So these are the steps for your binary installation. So first of all, create a MySQL user and MySQL group. Okay, so let me just first add the group here. Group add MySQL. You can assign a group ID also if you want, and user add MySQL, and the user name also I'm giving it as MySQL. User add hyphen R is for recursively, like we are creating the user, hyphen R hyphen G. this my first MySQL is the group name and the second MySQL is the username. So the group name also I'm giving as MySQL, username also I'm giving as MySQL. Group name is mandatory that you have to give the group name as MySQL only, but username you can give any username of your choice. It's not necessary that your user has to be as MySQL only for managing all your MySQL binaries. You can take any other name like XYZ or something and you can manage. But most of the environments, they try to have the user also MySQL only. So that like Oracle installations, when we are doing, we'll have an Oracle user. Same way for MySQL database, we are creating a MySQL user for installations. Okay, so a user, a group we have created. Now we just need to go and untar the file.
Okay, what is
So for
hyphen R is there for the user? Hyphen R is for the
hyphen
user,
R
right?
is for it's for recursively. It's recursively, like we are just forcefully we are trying to create a user there. Okay.
Oh,
Now
okay.
untar the
Forcefully.
file,
Okay.
untar
And
and
hyphen G is
unzip
for
the
the group.
file at a time. Yeah. Untar and unzip the file. It is at the same time there. So you can just say tar hyphen Z ZXVM. Z stands for unzipping because it's a gunzip file, GZ file, it's a gunzip file. So Z stands for unzipping, X stands for your untarring the file, okay, and V for verbosely, like whenever it is untarring, I just want to see what it is untarring, the files and all, and F is forcefully, okay. So ZXVF and just give the file name, tar.gz. So it is untarring and it is actually untarring into a directory by name MySQL 5.6.27. This is your directory structure. Like in Oracle, when you untar or when you unzip your Oracle installation files, it will be in uninstall. It will be untarred or unzipped into a database directory, right? So here, whenever I'm untarring or unzipping, it is coming into this bigger directory. So the MySQL version name, Linux, and the Linux, what kind of platform you're using, that is your 64-bit or 32-bit, the whole directory name is this one. So it's a very big directory name. Okay, so it will be difficult for us to
Right.
always connect to this directory name and use it. So what we do, we try to rename this directory. Or if you want, you can
I
create a symbolic link and always uses this symbolic link to connect to this bigger directory, or else better what we can do is you can just rename this bigger directory into with a smaller name. So it will be useful for you to always connect to this directory and you can see what are the binaries that are present in this directory. So in this directory, basically we get a bin directory, we get a var directory, um, we get some socket files. In MySQL, socket files are really very important. Socket file is nothing but a connection file. Okay, so MySQL, your socket file for MySQL will always be having like mysql.sock, S-O-C-K. Okay, so it's a connection file. So if your MySQL server is running, which means a socket file is created and it is running and it has a process ID also. Okay, a PID file is also generated there. So what do you mean by these files and all? Like when your Oracle server is running, your Oracle processes, when you just see, go and say ps-ef pmon, like when you just check the status, you will be seeing that there is some process ID for your instance. Okay, so here also when your MySQL is running, a MySQL instance or a process ID is generated. Okay, for your MySQL instance, a PID file is generated and a socket file is generated, which is used for your connection. So now my unzipping and untarring has been done. Now you can see that I have entered into this bigger directory, ls or llujc, and you can see here you have got a bin directory, you have got a data directory, documents are available, lib directory. Some scripts directory is there in which you will be having certain scripts. I'll be running the scripts to generate your MySQL server now. And some support files and all are available. So these are the binaries we have got when we have untarred and unzipped our software file. Okay, but this is a very big directory structure name. So using this directory structure name always will be very much difficult for us. So I'll just rename this directory into a smaller directory. So I'll just say move MySQL this file to MySQL 56. I'll just say some random name you can take, MySQL 56. So you can just see now my bigger directory name has been renamed as a small directory name. Okay, but this directory is owned by root user because as a root user only I have untarred and unzipped. Okay, but I want this directory to be owned by MySQL user. So now I need to change the group also I want to be as MySQL only. So I'm just changing the group and user name here. chon-r MySQL, just give it as MySQL 56. So here we have changed the group username as MySQL and group also as MySQL. Okay. So always whenever you're working with the MySQL 56 directory and whenever you want to make a connection, the user has to be the MySQL, the ownership with MySQL, and the group also should be MySQL directory. Done. So now I have got your binaries. It is just like I have just unzipped and untarred the file and I have got binaries. Now I just need to go and install your MySQL to get your data files. Now you can decide like where do you want to have your data files, where do you want to have log files and all. Okay, so for that thing I have a notepad also where you can just follow the document, practical document or a notepad also. This notepad also I have shared, which is like 1, 2, 3, 4 steps like what you need to do. So we have untarred the file, we have moved the bigger directory to smaller directory. Now the third step is run the MySQL install DB script. So what this script actually do is it tries to install some default databases in your MySQL. In MySQL, in Oracle, basically how your tables are stored. In Oracle, you'll have a database. Under database, you'll have certain table spaces. And then under table spaces, you'll have certain users, schemas, and schemas will be holding the tables. Right, under your schema it will connect to your user and will create certain tables. Now these tables will be under your table spaces and then your databases, but in MySQL it is not such. In MySQL basically you will be having you don't have a concept of table spaces. Basically in MySQL you'll have databases. Under your databases directly tables are stored. You don't have any schemas also holding the tables. So suppose now I just wanted to create an employee database, a company database I want to create. Our example I'll take in our practicals also I'll take a student database. Like I just want to generate a student database. So I'll create a database by name student, and under the student I just want to have multiple tables. Like I just want to have a class table, I want to have some marks table, then grade table, like what kind of grade the students will be getting. So all these tables will try to keep under your student database directly. So you don't have schemas holding the tables here in MySQL. Okay, directly
so then
they are
how
stored
do you
under.
organize them? You organize by the database name then?
Yes, by using database name. So you can have multiple databases for your multiple tables there. Like you had multiple schemas holding multiple tables, right? You can have n number of schemas, right?
Right.
So here in MySQL server, you can have n number of databases you can have. I can have a student database and student related tables. Then I can have a college admin database, then maybe some course admin database, and I can have that related tables. Like that, I can have multiple databases with multiple tables.
So
here,
single instance of MySQL and you have multiple databases inside.
multiple databases, right? You're right.
Got it. Okay.
You will be having a single instance but multiple databases there. And whenever I'm saying in MySQL install DB script, it will actually try to install some default databases here. So
Sure.
student, whatever the databases I'm saying, these are our own created databases. But when we are working with MySQL, you will be having some predefined, like a kind of data dictionary databases. Okay,
Right.
metadata.
Like
Okay, so what
metadata,
kind
kind of
of,
like a
yeah,
system table space.
yes, where you can have certain information about your MySQL and all. So there are 4 default databases that will be created in MySQL. So that 4 default databases will be generated when you run this script, MySQL install DB script. So let me run this script. So this script is basically available under stage directory only. Stage, just go to MySQL 5.6.
Mm-hmm.
cd MySQL 5.6 and cd scripts directory. Under scripts directory, you will be having this MySQL install DB script. So you just need to run this script, MySQL install DB.
So it's
As
only
which
one
user you
script
want to
listed
run
under
this
script?
script? Yes, only one script is available. You will be having only one script under this script directory, MySQL install DB. That's all.
Okay, got it. Okay.
So, and now you have to run this script, MySQL install DB hyphen user. So you have to run this script as a MySQL user only. Okay, because I'm running the script as a root user. Okay, as a root user, I'm initiating, but it is being run as a MySQL user. User equal to
Okay.
MySQL, then base directory, data directory, you have to mention.
So before running a script, do we need to create any directory or folders, or it's gonna create automatically everything?
And not required. Actually, suppose what here I'm doing here is I want to keep all my data and log files and all in this MySQL 5.6 directory only. I just want to keep it. Okay, but suppose you want to generate a new directory and you want to keep all your data in that new directory, then just go and create that directory first of all. Like example, I just want to keep all my data and all in some /u01/MySQL. Okay,
Right.
so just go and create that directory, then come back and just install DB script. You run the script. Okay, but what I'm doing here is base directory, I'm giving it as stage MySQL 5.6. Okay, so what I'm doing, the base directory, like Oracle base you are having, same way like MySQL base, I'm giving it as stage MySQL 5.6.
So the
And then,
base directory is more like where the binary, these installation files are right now.
yes, you're right. You're right. So if you want, you can give a different
Okay.
base directory here also. But for simplicity, I'm just choosing the stage
Correct. Correct.
itself as my base directory. So data directory, I just want to keep my
Yeah.
data
Wherever
here in
you're
stage.
correct. Wherever you have unload.
Yes. So
Got it.
data,
Got it.
I have a data directory. In that only, I just want to keep all my data and then just end it with a ampersand. Ampersand indicates end of your command here. So in Linux, the script,
Sure.
no more parameter or no more variable. I'm just going to define here after ampersand. It indicates end of
Right.
your command here. So MySQL install DB user base directory, then data directory. Always your data directory has to be under your base directory only. Data and ampersand.
So let me understand this clearly, okay? So
I'll just show you the
when
command.
you say the hyphen base directory equal, yeah, I'm reading the note that you have given me. So okay,
Okay.
just so
Base
hyphen,
directory.
right? Then hyphen data directory, is that where the data is gonna locate it?
Yes. There only you will
Okay,
be keeping all your data files and all your
okay, so we are
tables
telling.
and all will be stored there.
Okay, so we are telling my SQL. So I want to locate all my data file under data directory,
Directory. Yes.
and then you pass the directory where you want.
Yes.
Okay.
This is the
And
default things I have chosen. Like if you
right.
don't want to keep it in these directories, you can create your own directory of your choice also. You
Sure.
can go and see U01 MySQL data like that.
Okay.
Some
And what if
backup
we don't?
directories also you can create.
Okay. And what if we didn't pass base directory or data directory? It will create a by default then?
No, it will not create. Your MySQL install DB script, you have to define your base directory and data directory. So
Okay.
this is the issue with your banner installation, that you have to input it. It
Okay.
will
Can
not give
you?
by default values.
Okay. Can you open another session on your putty?
Another putty session?
Yes. And go to stage directory, new session.
So you want me to go to stage directory?
Yes. And now long
Stage
list and under MySQL
MySQL
5.6.
5.6. Okay.
So now where is data
Data?
folder? Oh, it
Yeah.
was there when we extract the zip file.
Yes. CD
Okay.
data ls, and you can see now it has got some data files here.
Okay, got
Some
it, got it.
default,
So,
because it is installed, it has got some files.
okay. And this is
Okay.
and also
So
the
now,
base directory is same thing, state MySQL.
yes.
Okay, clear. I'm clear now. Thank you.
Okay. So what exactly happened here in your MySQL install DB script? So we'll just scroll up and we can see here. We can read exactly what exactly this
Has done.
script has executed. Yeah.
Okay, cool.
Yeah, you
You
can
can
see here
done.
the command was here /
Yep,
MySQL install DB
yep.
user MySQL base directory and data directory I've given. Now what it is doing, installing MySQL system tables. Okay, like metadata tables it is installing here.
Can I ask you
Okay,
one question?
yeah.
At the installation, can we create a log file by passing
Yes,
a
yes, yes.
parameter?
You give log directory also. You can create log file directory also.
By
A different
passing a arrow key,
yes.
right
One
arrow?
more parameter you
And
can define, and you can give a different directory for your log files also. Because I have not given any directory, your log files will be created under data directory only by default.
No, I'm not talking about the database error log. I'm talking about installation log. When you do the installation,
Installation log directories like
Wh- all this command that it has ran script, right? It could throw all those under the one log, install that log, something like that, and you would throw everything in there.
like that kind of log file is not available, but if you want, you can write a
Okay,
script and you can just send them. You can
okay,
redirect them
not a
to
problem.
record.
Yeah, that's
You
what I
can
mean.
do kind of
Redirect it.
recording there. Spooling, if you want, you
Okay,
can do that.
sure. Okay, got it.
Okay, so installing MySQL system table. So you can see here what it is doing. First of all, it is actually trying to install your InnoDB memory tables. InnoDB tables it is installing. So what is this InnoDB basically? InnoDB is your storage engine. So in your next classes, we'll discuss more about the storage engines. Just understand here, storage engine
Sure.
is how you are going to store your data, and InnoDB is a read-write engine. Okay, read-write means what? It's a transactional support engine. Transaction, whatever the transactions you are doing. Transaction means what? You just try to do some changes. You try to do insert data,
DML
delete
operation.
data, modify your data. Yeah, DML operations. Any changes you do, those changes are permanent. Okay, so those are called as your transactions, and your InnoDB is a transactional support engine, which means it is similar to your Oracle databases.
Okay.
Like it is storing your data in an Oracle data file. Whatever the data you insert and you say commit, your data is permanent. It cannot be changed.
So
So
you
it's a
need a
transactional.
InnoDB. You need InnoDB for the DML operation. Do update, delete, or insert anything.
Yes, yes. Not only for DML, I can just say if you want your data to be permanent, like
Oh, permanent.
in
Okay.
any other engine also I can perform your DML operation, but they are not permanent, like they are temporary. Like you
Okay.
do changes, those changes are available till your um, what you call till your session is till your instance is up. After if suddenly your instance is crashed or something happens, you
Mhm.
don't have a guarantee that your DML changes are will be available. The
Recorded.
changes
Okay.
are not permanent like that. Okay,
I see.
but I know DB tables, the changes are permanent, and whatever you're doing, there is a guarantee that you'll be getting back your data. Okay, so why I know DB tables it has installed here. Okay, I am having another engine also, like we have got a MySAM engine, we have got some 6 or 7 storage engines also. But when I'm saying MySQL install DB, it has first installed your InnoDB engine and InnoDB related files only, because from 5.5 onwards, the default storage engine is InnoDB. So when we are
Okay.
working with MySQL, we have got something called as default engine also. Okay, like when you are working with Oracle, you'll be having some default temporary table space, default undo, right? Same thing
Yes.
here also, like when we are working with MySQL, we are having this default storage engine, that is InnoDB engine. So till 5.5, before 5.5, we had this MySAM engine as the default, MyISAM. But from 5.5 onwards, they have made this InnoDB as the default engine. So whenever I'm installing this, so we are working with 5.6 MySQL here, right? So
Yes.
that's why whenever I'm installing, InnoDB engine is installed here first, and we are getting InnoDB files here. So in detail, we'll discuss about these files in your storage engine class. So where I'll be creating some InnoDB tables, and we'll see what kind of files you are having in detail. Now just
Sure.
understand that for InnoDB, you'll be having a data file by name IB data1. One InnoDB data file is generated. 2 log files are generated for InnoDB, log file 0 and log file 1. 2 log files and 1 data file is generated for InnoDB. Okay, and
Okay.
after
The
that,
log file is kind of like a redo log file as an
yes,
Oracle.
yes,
Okay.
you're right. Kind of redo log files.
Okay.
So whatever the changes you are making, those changes are available in those log files.
Okay. Now I see this
Okay.
LSN number on this
Yes.
LSN 45781 log file created. What's that mean? Right underneath the log file being created, right after the log file created.
Yeah,
Yes,
log
there.
sequence number.
Okay, log
It's a
sequence
log.
number.
Yeah, it's a log
Okay,
sequence number that is going on. So InnoDB new log files are created and some random number is given there.
I understand. Okay, got it.
So some
Thank you.
random number is given there. And after that, after your InnoDB file system is generated, you will be getting a root password you have to set here. Okay. So what is this root password basically?
Hmm.
After setting this InnoDB things here, so you will be
Sure.
having something to go and set a root password for your MySQL root user. So what is this MySQL root user? So whenever you're doing MySQL database installation, the default
Mhm.
database, when you're running this script, a default root user is being generated for MySQL. And this root user is not at all related to your OS root user. Like Linux has a root user of Linux we are having.
Right.
Okay, that is not similar to this root user. This is
Okay.
your
Now,
MySQL root user.
okay. So these are the root is a two different user.
Yes, 2 different root users you are having. One is for OS, that is Linux.
Right.
Now for MySQL, we have got a new MySQL root user. This root user is like the super user.
Okay,
Like
got it.
in Oracle, we have a sys user who is managing the complete shutdown and
System.
startup of your Oracle sys
Yep.
user we'll be having, right?
Correct.
So whenever we want to connect and all, like same way in MySQL, when we have run this script, we have got a root user. So whenever I want to start up your MySQL server, shut down your MySQL server connection, anything I want to do, he is the super user. MySQL root user is the super user. So this root user is generated, and now I need to go and assign a new password for this root user.
Okay.
Okay, so because some random password is allocated for this MySQL root user, which you don't know. So how do you go and assign the root user password? It is saying you just need to go and run this command, MySQL admin -new root password, and then give the new password. Okay, using this command, you can run this MySQL. You can assign a new password, it is saying, for this MySQL root user. After assigning the password and all, if you want to, you can actually start your MySQL in MySQL D safe mode. What is this MySQL D safe mode? Suppose I don't want to assign a root password at all. I
Okay.
just wanted to go and start up my MySQL server. So you can start your MySQL server in safe mode. Safe mode means you don't need to provide any MySQL root password, and simply you can just go and log in without any. You are bypassing the root credentials there.
Okay, but when you start with safe mode, it still function as a normal database then?
No, it will not be. Your users cannot connect in safe mode. Okay,
It's
it's
just
like a
for
no mount.
the
It's like a
okay.
mount stage you can consider in Oracle. In
Okay,
mount
got it.
stage, what you do, like any kind of admin operations or anything you want, you can perform, and
Right.
you'll be having, you don't have an access to all your data dictionary information and all. This is just simply like maybe immediately you just
Maintenance
want
mode.
to log in, like a, yeah, kind of maintenance mode you want to enter. You can go with your safe mode there.
Okay.
Okay,
In this
then
maintenance mode, if you forgot the password, you can change it in this maintenance mode
change.
then?
Yes, you're right. I'll show you in
Okay.
your next class how to change your root password. Like maybe you want to change your root password, or you forgot your password and you really want to change it, you can do it.
Okay,
So we'll
got it.
see that. That is one good thing, because we mostly we try to change the root password frequently there. Like every 2 months, 3 months, we try to change the root password, because if somebody accidentally know this root password, they can just log in and they can just modify anything,
Yes.
your
Or
tables and
the
your files
for the
there. So
company's policy, whatever that is.
yes, so in this safe mode, we can go and change your root password. Okay,
Okay.
and any more information about your MySQL you want to know, you can just go to your mysql.com, and licensing information and all, you can go with your shop.mysql.com, you can know it. And whenever I didn't give any configuration file location. I just gave only data file location and a base directory I've given. If you
Right.
want, you can give a configuration file location also. But I didn't give that. So a new default configuration file was created under your base directory. So what is my base directory? That is stage MySQL 56.
But didn't you
Stage
say the
MySQL.
last, yeah, didn't you say the last session, last session, the my configuration file is under etc
No, etc. It was there in before
5.5?
5.6, not 5.5 also, before 5.6 till
Okay, before.
5.5. Till
Okay,
5.5, your MySQL configuration file was there in etc/etc
okay,
my.cnf. It would be generated, but
right.
that location is only for your RPM installation.
Oh,
But
okay,
for
not
binary
the,
installation, yeah, that location etc also will come up only for RPM installation. But for binary installation, it will take whatever the base directory you have chosen, that it will take. But if you feel that I don't want to keep my configuration file in base directory also, you can define your own directory also. You
got it.
can say that my configuration file has to be there in some /xyz location. So you can keep there also. It's your
Okay,
choice. And now from 5.6 onwards, if I'm going with RPM installation, it is not etc location. It is in /usr location. So in your next class, we'll see how to do your RPM installation. So there you'll see that when I just go and install your RPM, do your
right.
RPM installation, a default configuration file will be created under your USR location. USR location, you'll get a file by name my.cnf.
Okay, got it. Yeah, that I have it now.
Okay. So you can see that new default configuration file is created and will be used by default by the server when you start it. So these are the things that happen when you done your MySQL install DB script. All your InnoDB engine was started, and InnoDB data file, InnoDB2 log files were generated, and then a MySQL root user is generated, and it is asking us to set the root password here, which we need to do it now. And
Okay.
later on, it is asking us to, if any more information you want, you can go and check in mysql.com, and it has generated a new configuration file under your base directory. Okay, so these were the things
Right.
that happened when we run this MySQL install DB script. Then later on, next step, after next install DB script,
Okay.
you can go and start your MySQL server. Okay, so you can start in safe mode, because my root password is not yet set here. So I'll just start in safe mode
Right.
and then go and set a new password for my root user. So let me just go to your system again. Okay, so I'm coming out again. Now cd stage directory,
So right now the
stage.
MySQL engine is now running, correct?
It's not running. Only the install
Okay.
DB script has been it
Done.
has just generated some base tables and some file system for InnoDB. It has generated. That's all.
Right. Right. Okay.
So now I just need to go and start my MySQL server. So stage MySQL 56. Under
Right.
that you are having a bin directory. So under bin
Right.
directory you can find, so if you want you can see what are there in your bin directory. CD bin
Sure.
directory, you can see all your executables are available, all your scripts are available. The MySQL save, utilities are there, MySQL dump,
Mm-hmm.
MySQL import. So we'll be using most of these utilities, MySQL
Sure.
secure installation. So a lot of
Okay. Yep.
scripts are there. So let me just run this thing here, /bin MySQL d underscore save hyphen user equal to MySQL.
Mm-hmm.
That's all. You can just end this command. End it with a ampersand. Okay.
Empty. Okay.
MySQL D save mode as MySQL user, then just end the command. And you can see here now my MySQL server is started.
Yep.
And it has actually generated a new error log file for you. So this error log file in detail we'll see in your
Correct.
all log files and classes. But understand this error log file will be recording all your startup and shutdown issues of your MySQL server. So whenever your server is starting up or shutting down, any issues are available, you can find it out that in your MySQL error file. And your error file name, you can see it has been given as your hostname.err. So my hostname is
Correct.
mysql.kts. And some err extension. Okay, so it has been started in safe mode here. Now, if you want, you can just check it over here. ps-ef
Great.
grep MySQL. So when I just say grep MySQL, it will be listing you all your MySQL related, because your MySQL server is running, all your processes related to your MySQL it is showing. So
Yep.
you can see where is the data directory, where is my user, where is my error log directory. Okay.
Okay.
And the process ID file is also generated. APID file, like I've told you, like whenever your MySQL is started, APID file is generated, which will be basically holding your process ID. Because whenever your MySQL is started, instance is started, it is running as a process, like a PMON in
Okay.
Oracle. Process ID is given there. So same way here also it is given there. So if my MySQL server is not running, you cannot see any of these MySQL processes running over here.
Okay.
So now my MySQL server is running, so it is showing here. And one more thing, like if you're completely new there, like
All
here,
right.
the data directory and all I have just kept here. Maybe tomorrow if you join a company and your MySQL server is already running and you really want to see where your data directory, where your log files are present, all
Yep.
your data files are and all present, just check with this command ps-ef grep MySQL you say, and you can see there where
Oh,
is your
okay.
page
Perfect.
directory and data directory available.
Okay.
Okay,
Yep. I will check
so
that out.
yes, so you can know where exactly your data files and all are present.
Add a log file and
So
everything.
right now my MySQL server is started. Now what I
Yep.
have to do, I have to go and set your password here for your MySQL root user. Just go and say stage MySQL 56 bin directory. We are having a
MySQL admin.
utility MySQL admin. Okay,
Right.
so MySQL admin
-u
-u root
password. Single quote MySQL.
password. Any password you can give. I'm just giving the password as
Yes.
something MySQL 123. Okay, so
Yep.
this is the, so using the password on the command line can be insecure. It is just giving you a warning. Okay, anyway,
Oh,
because
okay.
this is the first time I'm setting, anyway I have to use it command line only. So now my
Right.
root password is set here. Okay, so
Okay.
my MySQL server is started, my root password is set. Now I just need to go and connect to your MySQL server, like your instance. I have to connect. Okay,
Right.
so for connecting to your instance, you can just say cd stage directory MySQL 56. Just be in your stage directory MySQL 56. And there is some trick here for always whenever you are connecting, you have to be in bin directory, and from bin directory only you have to execute your um, connection command. Okay, so
Okay.
the connection for connecting to your MySQL server will be using a utility called as MySQL
MySQL.
utility, MySQL -u root is your MySQL root user, then say -p. What is your MySQL password, root password I have given? That is MySQL 123. So I'm now connected to your MySQL instance.
Okay.
So you can see your MySQL
Version.
server version and the connection ID is given. Like you remember in your architecture class, whenever a client wants to connect, okay,
Yes.
whenever a connection is made to your MySQL, so a connection manager takes the request and it gives to a thread manager, and a thread or connection ID is generated there. So for every time when you are connecting, you'll be getting a different
New ID.
connection ID here. New ID will be generated, and this is your 5.6 MySQL version I'm using here. So I'm able to connect to your MySQL server. So what are the default databases that are generated and default base tables that are generated? So in MySQL, if I want to see those things, you can just give the command show databases.
Correct.
Basically, MySQL is also internally using SQL language only, but it's not
Different command.
completely all your SQL queries. You'll be having certain different commands also. Like in SQL, in Oracle SQL, maybe you have never used show commands there,
No.
right?
Right. Yeah.
So we'll always say select. Mostly we'll say
Right.
select command and all. But here, suppose
Correct.
I want to see something. I just want to read something. I'll say show. Show databases, show tables, show parameters, show variables like that. Okay, so when
Got
I
it.
say show databases, you can see you have got four default databases here. So we have got information schema, MySQL, performance schema, and test database.
Okay.
Okay, so these are the four default databases that you have got. Okay, so we'll see in detail about these databases also. Like
Sure.
information schema, it will be in your next classes, we'll see there. After your RPM installation, I'll explain what are these default databases, what tables exactly. Like we
Yep.
can connect to these databases and we can see what are the base tables. Some default tables are also available under these default databases. Like data dictionary, metadata tables are also available there. Okay, so
Okay.
just understand that show databases, it is giving us some four default databases. So let me exit from here. Okay,
Okay.
now my MySQL server is running. Okay,
Right.
my MySQL, we have successfully done your binary installation. I have given our own choice of base directory, data directory we have given, and we have set the root password. Now for connecting to your MySQL server, I have to always be in your bin directory and then give your MySQL utility for your connection, right? Now,
Yep.
I just want to shut down your MySQL server now. For shutting down also, you have to be under your bin directory only. Under bin, MySQL admin utility you have to use for your shutting down. MySQL admin
Okay.
shutdown -p -u root -p you have to give. Shutdown
Hyphen euro or hyphen
-u root -p.
P.
So it will
Password.
ask me for the password there. So just provide the password, MySQL 123. So
Okay.
now your MySQL server is down. You can see when your server is going down, you can see your PID file got ended, it is saying, which means it is killing your instance. It is killing your instance, it is killing the process file, and PID file got ended and your server is coming down.
So what is the collected in PID file? Anything?
It will be having the process ID number that
Okay. Got it.
basically a separate file is generated here. Like in Oracle, your process ID, like pmon, if you just check ps-f grep pmon, for
Yes.
your Oracle instance, you will be getting a process ID there, right?
Yeah.
So it will be just visible there. But here a file is generated when your server is coming up, and when it is shutting down, this file gets ended. Okay, so it's
Okay.
done here. Now
So the
to
file is
confirm that
now,
your
since you shut down, the file is there under my MySQL data, the
yes,
PID
yes,
file.
the PID file will be there, but your
Okay.
it just
Engine is stopped
what do you
now.
call it? Yeah, it stopped the process ID that was, it just killed that instance process with
Correct.
that process ID number. So if I now just go and check here ps-ef grep, my MySQL server is not running here. So it
No,
is not at
right.
all showing any process or anything over here.
Correct.
Okay, so if you want, you can just go and check in MySQL 5.6 data directory. If I go and check here, okay, your PID file is also deleted here. It is
That's what I
ended
mean.
means it is gone. Yeah,
Okay.
it is gone.
So it's only
So when you
when its
start
database
up, a
is
new
live, that's
PID
the
file
time
is
is
generated.
okay.
Yeah, when you
Only
just start up, a new PID file is generated.
yeah, because the new PID will be assigned.
Yes. So here what we have done in, so this completes your binary installation, but it is more kind of tricky, right? I want
Yes.
to connect to your MySQL server, I'm using MySQL utility. For shutting down, I'm using MySQL admin utility, and there is always one thing that I have to be in bin directory only for connection and disconnection. Okay,
I see.
so for all these things, to avoid all these issues and all, like again, later on also, like for management on all also, because binary installation we have to define everything. The MySQL configuration file, you see, like I have got a MySQL configuration file also, stage
Yeah.
MySQL 5.6.
5.6 data.
Under that you have got this my.cnf file.
Correct.
So if I just open this file, okay, some default directory it has been given here. So you need to go and set this. You need to go and set this configuration file. Okay, so emphasis indicates like it's all comments. Okay, so these values
Yeah.
are not being used there. So
Not being
you
used
can
right
go,
now.
yeah, you can go and set your own values and all, and you can just give the values here. Like you can see here, a port number parameter
Yeah.
variable is available here. Port. Like
Right.
default port number for MySQL is 3306.
Correct.
Okay, but suppose if you don't want to use that default port number, you can actually go and define here in MySQL configuration file port equal to some, you can mention it as something 1015, any number
That
of your
one.
choice. Again,
Okay.
there is no range.
Okay.
There
The
is no
port you
range
can
of port numbers here.
assign after the installation, right?
Yes, after the
Or
installation, you can define your port number
okay.
in the configuration file.
And what is the server ID mean?
Server ID is like when you're working with multiple MySQL servers there, like in your replication class, I'll show you. That will
Okay,
identify the uniqueness of your server. Like
I see.
suppose I
Okay,
have two or three MySQL server, which are like one server is sending the data to multiple MySQL servers. It is
master
replicating the
slave
data to multiple servers. So how can I define, how can I, even though host
identify.
names are given there, it should be having the unique numbers assigned for those servers. So
Got
like
it.
for master, like the primary server, I'll give the server ID as 1. Then
Sure.
secondary servers, I'll give the server ID as 2, 3, 4, 5, like that. So
Got it.
that will be your server IDs. Okay. So now we'll just quit from this file. So it's
Sure.
some default random file is generated. So my binary installation is done, and we were able to successfully assign the root password, and we have connected to the server, and we disconnected or shut down the server. Now I just want to go and completely remove this binary, uninstall your binary installation, remove the binary installation from my server, because
Okay,
next we'll be doing your RPM installation. For RPM installation, you should be not having any kind of MySQL installation running in the server.
I see.
Only
It
one
should be clean.
installation, when you're doing RPM installation, only one MySQL installation can be in that server. If you're already having a running MySQL instance is running, you cannot go and do your RPM installation then. Okay,
Okay,
so I just need to go and remove this one. So for removing, it is just simple. That is, you need to first shut down your MySQL instance, which we have already done. And after shutting down and
yep.
all, what you have to do, just go to your uh, CD stage directory. You can go
Okay,
stage directory, just remove this MySQL 5.6 directory, because everything is there in your MySQL 5.6 directory, right?
I see. Okay, nothing,
R2,
no other files are copy anywhere else.
no,
Library file.
never. Yes, because you have defined where your base directory and where your data directory will be there, right?
Yes,
So in no other directory, nothing, no temporary files, nothing has been generated in any other location. So you
got
can
it.
just go and remove all these things. So I'm just removing the zip file also, because it is not required
Installation
for
file.
me right now. So everything I'm just removing it from your stage directory.
Got it.
So you'll be just removing all the installation binaries, and all everything will be removed. But before removing, make sure that your instance is down there. So your
Okay,
MySQL server is down there, and I have removed everything. So this
got
will
it.
actually now stop your MySQL binary installation. It's done, and nothing is there in your stage directory now. Now, next thing, we can go and install your R2, your RPM installation. So for RPM installation, we have already copied your RPM bundle also. Like last class, I have downloaded your RPM
Yes.
bundle also. So that I need to copy it here in your stage directory, and then do your RPM installation.
Okay.
So
Yeah,
for
I
the
have
copying,
everything
again,
ready.
I'll use
I have a
WinSCP.
practice.
Yes. So now again, we'll use WinSCP, and we'll just try to copy. 106 to 56. Most of the people, when they are doing this MySQL installation, nobody will see this binary installation, because it is not much used in actual environments. So most of them, they'll go with the RPM installation only. But actually binary installation also exists, and some of the clients, they just insist on binary installation only, because they say that, okay, let it be, but I just want everything to be under our control. Like I don't want to have some default values. And when we are doing RPM installation, you will be having lot of files generated in lot of locations. You'll have temporary directories, varlib
Right.
directories, some files will be there like that. So uninstalling your RPM
Okay.
installation, it will take time there, uninstallation.
So
So
uninstall
just
won't be
go for
not easy as binary install.
binary installation. Yes. See the stage directory. And on my Linux machine, I was in stage directory. Now I need to copy the RPM bundle there. So I'm just taking 5.6.29 and just drag and drop.
Yes.
What is this RPM bundle? It
You
is
know,
having some 5 or 6 RPMs bundled together. Now I just need to untar this
uh-huh.
bundle so we get these 5 or 6 RPMs. So these RPMs only I have to install. That's all. There are no more scripts
Right,
that I
right.
need to run. No need of running in safe mode or anything. Nothing is required here. Okay, so everything
Okay,
is
got it.
automatically created. A configuration file is generated at the default location will be USR my.cnf location. A configuration file is generated, and all your files will be located under default directory, that is var lib mysql slash var lib.
Uh-huh.
Under var lib mysql directory, all
Including
your data
including
files,
data
log
file.
files, all your binaries, including all your data files and all.
Okay,
So it's like a base directory will be your
got
var
it.
lib mysql directory, and you cannot change
I
this at the
see.
time of installation. At the time of installation, you cannot
Okay.
change this default directory also. Whatever the directory is there,
Anything.
you have to go with that. After that, if you want to go and change, then you have to move all your data and all to some other directory. If you want, you can move it.
And update your config file, right?
Yes. So now you can see I've got this stage directory, I've got this RPM bundle. So under this
Yep.
bundle tar hyphen
Yep.
xvf MySQL. You can see I've got this test RPM, server RPM, devel
File.
RPM, client RPM. So I just need to go and run these RPM. So we'll do that in your next class. Okay, so we'll install these RPM. So
Okay.
when I'm installing these RPMs, only all your INODB based tables, data dictionary, metadata tables, everything will be generated. So no need of going and running any new script here or anything. Like in binary installation, we have run this MySQL install DB script.
Right.
But here it is not required to run those scripts and all.
Okay.
Okay,
What about
so we'll see that in the
my SAM? My ISAM.
my SM actually INODB is the default, so all your default engine tables and file system is being generated. But suppose I
Okay.
want to have your MySAM engine, or you have some 6 or 7 other engines, so you have to explicitly go and create those files system.
Oh,
You have
so
to
we
go
have to
and create
install
it.
those individually.
Yes, individually whenever you have a requirement. Because now
Okay.
default is INODB everything. If I'm just going and creating a table, it will be created under INODB table engine only. But suppose you have a requirement that you don't want to use INODB, I want to use MySAM or federated engine. Multiple
Right.
engines are available, and explicitly you have to define that which engine you want to use and what kind of files you want to have in that, and all we have to define. So that we'll see in
Okay.
your storage engine classes. Okay,
Okay.
so we'll see that
Okay.
next class. Yeah,
Okay. And now
so we'll
one
stop
more
it over
question.
here for today.
Yeah. Now
Yeah.
the
This conference will now be recorded.
Okay, so last class we have seen the binary installation, that is also called as source code installation, because uh, basically we were taking everything from the scratch, like we need to set up everything there. Okay, so that is, and we had the a gunzip and tar file that we have untarred and unzipped, and then some scripts we have run to get your default databases. Then for connection, we have used MySQL utility. For shutdown, we have used MySQL admin utility for shutting down your MySQL server and all. Okay, so last class I have copied your RPM installation file also. Now we just need to go and start your RPM installation. Okay, so we have copied your RPM installation zip file into this, and I think yes, I have unzipped also, so that I have got all your required RPMs for your MySQL installation. Okay, so these RPMs you have to install one by one in the same order that is given in your book, because your server RPM should be installed first, devel should be installed first, then your client should come up. You cannot go in a random way here. Okay, so you have to go with your exactly, you should follow the order that that is given in the document. Okay, so first we'll go and install your shared RPM. Okay, so the first RPM we have to install is your RPM-IVH shared RPM. Let me just say ls here so that I'll get all the RPMs here. Okay, RPM-IVH shared RPM. So this kind of RPM installation is simple. It is just installing these RPMs. That's all. No need of running any scripts or anything, and your MySQL server will be started. It will be set up and it will be started. Now next RPM, RPM-IVH devel RPM you have to install. Then next is embedded. Okay, then next is server RPM. This is in this RPM you will see what exactly is happening here. MySQL server RPM. So when we are running this server RPM, in binary installation, we have run a MySQL install DB script where your INODB default files, log file, data file, and a configuration file is created. Same thing happens here in this server RPM. When we run this server RPM, the complete INODB file system is generated, a MySQL root user is generated, and a password, random password is assigned to that root user. A MySQL configuration file is generated here. Okay, and the default location of configuration file from 5.6 onwards, it is usr/usr my.cnf. So you can see here INODB files it is generating. IB data file, IB log files. Then it has generated a MySQL root user, it has generated. You must change the password on your first connect, it is saying. When you're first time connecting, you have to change your password. No other statement but set password will be accepted. Okay, it is giving us also like how do you need to go and set your root password there. Because with RPM installation, a random password has been set for your MySQL root user. But whenever you are connecting to your MySQL server for the first time, it is mandatory that you have to change your root password there. Okay, so this I'll show you how to change your root password. This is not the case only for when you're doing the installation for the first time. Maybe later on you want to change your root password, then also you can follow the same steps there. Okay, so we'll see that steps now. Then next is a default configuration file is generated under USR location. This is something new location from 5.6 onwards. Below 5.6, your location was etc/etc. We used to have the configuration file. Okay, so you can see here when I just ran the server RPM, I have got all these things. And then next is test RPM. This test RPM actually tries to generate a test database there. Sorry, client I have to install, then test.
Okay. What is the
hyphen
hyphen?
IVH.
Yeah. What is the hyphen
IVH?
IVH? Yeah. V is for verbose.
Yeah. Actually,
I
when
for
we are in
install.
I for install, yeah, you're right. I for install. Okay. So
And H stands
whenever
for.
H, I really don't know what H
Okay.
stands for. It is like something Linux command, something like suppose when you want to install any RPM, you have to give this IBH. This is for
Correct.
normal installation, but when you
Yep.
want to forcefully install, then you'll get UVH, you will give. Okay,
Okay.
UVH. U is for your updates also, it will be going. Okay, if any kind of updated RPM is there, then that also gets installed there. Either you can use UVH or IVH.
Okay.
Okay, and lastly, we'll go with your client RPM, test RPM. This test RPM basically tries to generate a default test database. So when we have run the server RPM, in that the test database was not generated there. So in MySQL, by default, you'll be having 4 default databases. That is test database, MySQL database, information schema, and performance schema. So this test database was not generated at the time of when you run the server RPM. Now we need to separately run this test RPM so that a test database is also generated. Test database is really very important when you want to perform any kind of testing. Test tables or anything you want to do, some temporary tables you want to keep, you can keep it in your test database.
Okay.
So with this, now your MySQL server is completely installed. Now I just need to go and start your MySQL server and then connect using your MySQL root user. But MySQL root user, we need to assign the password there. So your MySQL server is completely installed. Now let me just check that is your MySQL server running or not. ps-ef grep MySQL. If I just say your MySQL server is installed, but it is not running. It is not yet started. So I just
Correct.
need to start your MySQL server. For starting, we'll give the command service MySQL start. So from now onwards, when you're using your when you done your RPM installation, for starting up your MySQL server, you'll use your MySQL service. Okay, we'll give the command as service MySQL start. Now your service is started. Now you can just go and check. Again, just check ps-ef grep MySQL. So you can see all the processes that are running for your MySQL. So where exactly your data directory is available? Your data directory is
Wireless.
there in varlib MySQL. So have we
Correct.
have we defined this directory structure? No, it
Nope.
is by default. Okay,
Correct.
and at the time of installation also, many of them they say that can't we keep the directory structure at the time of installation? You don't have an option there because we just ran certain RPMs and your MySQL server got installed there, right? I didn't have any
Correct.
choice to go and give a directory structure there, right? So default location is varlib MySQL, and a process ID file is also generated under varlib MySQL by name hostname.pid. Okay, and this is your data directory user MySQL. Log file is also generated here by name hostname.err. Fine. So by this you can actually know that if your MySQL admin has changed any location, then also you can check here grep MySQL. If you say, then you can actually know where exactly all your data directory, all your data files and log files are located. So now my MySQL server is running. I just need to go and connect to your MySQL server. So for connecting to your MySQL server, we'll give the command, we'll use your utility MySQL. Okay, MySQL utility will use for connection, and whenever I want to shut down also I'll use MySQL utility only. Okay, but for connecting to for connection, like you remember last class for your binary installation also we have used this command, but we always have to be in bin location for binary
Right.
installation. My /bin MySQL -u root -p, then it will prompt you for the password, but I don't
Correct.
know the password now because some
Ah,
random password was generated at the time of installation. I cannot
correct.
use that random password also because that will be in a completely encrypted format or something. So it is always recommended that you need to go and set your password now. So how to set your password? So without password, I cannot log in also now here. Access denied, it is saying. Okay.
Correct.
So now we'll go and set the root password here. So for setting up the root password, I first need to log in into your MySQL server. Okay, so how to log in into your MySQL server without your password? Last class I have told you we have something called as MySQL safe mode. Okay,
Okay.
safe mode will allow you to log in into your MySQL server without any password. Okay, so without any password, let me just log in into your MySQL server. So I have the steps for setting your root password. I've sent you this notepad also, so you can follow these steps for either first time setting or whenever you want to reset your root password also, you can follow the same steps. Start your MySQL server in safe mode. Okay, so first of all, I just need to go and stop your server because my MySQL server is running here. So
Yeah.
service MySQL
MySQL stop.
stop. Okay, so my MySQL server is stopped here. Now next step is start
Sudo
in safe mode. Okay, so there is one more option here when you are starting in safe mode. Either you can say MySQL D safe. So like last class we have used this MySQL D safe mode. Okay, or there is one more option here, MySQL D safe. In MySQL D safe, we are having something called as skip grant
grant.
tables. Skip
Okay.
grant tables is grant tables basically will have all the necessary privileges or permissions that are required for a user to connect to a server. Grants
I
means
see.
what privileges, permissions we are granting. Okay,
All
so
right.
whenever I just say script grant tables, we are not allowed, we are asking your MySQL to skip any kind of privileges for your root user and allow your root user to connect to your MySQL server. Without any privileges or permission, we are asking your root user to connect to your MySQL server there. Okay, so I'm using a sudo user here for a connection here. Sudo is nothing but a random temporary user we can generate. Instead of root user, we can have a sudo user for making a connection. This is in
Okay.
Linux basically.
Okay.
Sudo MySQL D underscore say
Hyphen
hyphen
escape.
skip
Hyphen grant.
grant
Hyphen
tables.
table.
Okay, hyphen
Okay.
hyphen script grant table. So this is now it is logged. We are able now we are logged in, but it will be like a ongoing loop. I cannot disconnect from this session and I cannot allow you. It will not allow you to connect from here only. So I just need to open another new session and
Uh-huh.
from there I can log in as a root
So
user.
it won't
So
give you
let
the prompt
session
back.
be as yes, it will give you the prompt back. Log in as root MySQL 123. Now you just connect here MySQL hyphen u root you just see. Without any password you will be able to connect.
Okay.
Okay, can you see here? So
Oh, I can
MySQL
see it. Yeah.
hyphen u root I've said. I didn't give any hyphen p or something and I'm able to connect to your MySQL prompt.
Correct.
So the MySQL version I'm using is 5.6.29 and I'm able to connect. So here I can just work. It's like now it's like you're in maintenance mode kind of thing. Your
Uh-huh.
users cannot, no, they cannot connect. Only like, as a root user, you are able to connect. Okay, any kind of maintenance operations, anything you want to perform, you can do it over here. It's not like it's like your database is not completely open for all your users, clients to connect and to work. Okay, so show databases. Now I can see the number of databases here. We have got information schema. MySQL is a database name also here.
Okay.
Mostly in MySQL, group name is MySQL. User also we have created as MySQL. Database name is also MySQL here. Okay, and we have got a performance schema database and test database. So basically, we'll see here what is there in your MySQL database. Okay, so how to connect to this database here? So if I just need to say, give the command use MySQL. Use means try to connect to your MySQL database.
All right.
Use MySQL if I say, then I'm able to connect to your MySQL database. But how to confirm that I'm connected to MySQL database? You can select with this function. You can just check here, select
Mm-hmm.
database. So when you just say select database, you can see here you are actually connected to MySQL database. The database which you are rightly connected is MySQL database. So you
Okay.
can go and create n number of databases in MySQL. These are the 4 default databases. You can go and create n number of databases in MySQL
Now,
server.
how would you go back to the previous?
Previous screen you want to go back without any database selection, you can just
Yes.
exit. You can just exit and reconnect. But
Oh,
from here
okay. But
only
you
you want
cannot
to
be
go
in
to.
you cannot be in a prompt and go back to the previous screen.
No, previous screen we cannot go back. But if previous any other database, I can go and connect.
Yes,
Like
that I was
yes,
able to do yesterday.
yeah,
With the
database I can
binary
go and
storage.
connect. Like
Okay.
use MySQL, I'm now connected to MySQL database. But if I
Yeah,
want to
you
connect
test.
to test, use
Yep.
test. Your database
Okay.
got changed. Now you are connected to test database. So
Now,
from one database to another database, we can move.
how about you can query all the database, which database are from this test database location, or show databases works?
Show databases,
Oh,
it
okay.
works.
Okay,
We can
then
see
we
from
can switch back and forth.
yes.
Okay.
Okay, now I need to connect to MySQL database because MySQL database has a table by name user. In that user table, we have a root user and we need to change the root user password in that table there. Okay, so use MySQL. Let me just see that what are the different tables we are having in MySQL database. So we'll give the command as show tables. Show tables will give you all the tables that are available in your MySQL database. So we have column privileges table, a DB table, databases table, events, functions, general log, help tables are also available. And then we have got servers table. You can actually know what are the different server IDs and servers available. Slave master info, like when you're working with your replication in your
Right.
classes, we'll see replication where we'll have your master slave configuration, and also we can actually see there that information. Table privileges we can see. Then lastly we have got this user table. This is
User.
a very important table, so that will actually hold all your users information. Okay, so right now how many users I'm having for your MySQL server? Only one, that is root user, right? So let me
Okay.
just go and see this root user information. Just say describe user table. So I've got a lot of columns in this user tables.
43 column.
Describe user, you can see here you are having host name, username, password, and for the users you can have your select privileges, insert, update, shutdown privilege, and all those privileges. Okay, lot of things.
Correct.
So let me just see select host name, user, password. Anyway it will be in encrypted format only. Select host user from user table. So you can see 4 rows it is showing you, and the user is, who is the user here? Only root user.
Root
Because
user.
at the time of installation only root user was generated. Okay, default user is root user. He's the super user. He's the super user, but 4 times this user information is recorded in your database here. Why? Because this root user actually can connect your MySQL server using the fully qualified host name, that is your mysql.kts.com, with your domain and all. This root user can be able to connect. Or if you say local host, then also this root user will be able to connect. Okay, so I can just say uh, username @localhost, root @localhost, and I want to make a connection, then this root user will be able to connect either by using fully qualified name or localhost, or colon one is also locally connecting only, and or you can give the subnet also. 127.0.01 is your subnet. Using this also your root user will be able to connect. Basically,
Okay.
MySQL is allowing you to connect either of these options. If you use, then your root user is able to connect to your MySQL server. Okay, there is only one user, but different host names
Host
it can
name.
use, and it will be able to connect. Now I am having the root user. Now I just need to go and update the root user password here. Some random password has been assigned. So we
Right.
just need to go and update this root user password in user table of MySQL database. Okay, so after connecting, now we'll give the update command. We'll just say update user table set password equal to, because password is a column here, set password
Yep.
equal to password function,
Yep.
password function, password, and I just want to give the password as something MySQL123, where user equal to
Root.
root. Okay, so you
Okay.
can see the same command over here, where password equal to, where user equal to root.
Yep.
So update user set password equal to password function where user equal to root. Password function when we are giving, because we are not giving a what you call the a text to password here, because this password has to be loaded to your table as in encrypted format. Okay, not as a
Okay.
text format. That's why we always give it as a password function, then give your password then.
Okay.
Okay, so your 4
And this
rows
is
has been changed and your root password is set now. Okay, if you want to see your password also, but you cannot see that password anyway in encrypted format will be there. If I just say
right.
password here, password from user table. So now your something password is assigned, that is MySQL123 is our text to password that is assigned here. Okay, so now after your password is assigned, you can just go and close the session there. Directly close the session that
Oh,
was running when it was
okay.
running, right?
I
So
see.
you just cancel the session or you can just close this session, that's all. Okay,
Okay.
after closing the session, you can just exit from here.
Sure.
Okay, and now you just need to go and start your MySQL server.
With the service start MySQL.
Yeah, service MySQL start, you just say service MySQL. First you can say stop,
Sure.
because it was running in safe mode. Then you can
Right.
just say start. Service MySQL start. Okay, now your MySQL server is started. Now you can make a connection here. MySQL -u root -p. I have assigned the password here, so I'm able to connect with the password.
Yep.
If I
Okay.
restart your password provision, then I have just given the password. Now I'm able to connect there. But you are able to connect there, but you cannot use any databases information. If I say use MySQL or something, any database I want to connect, again it is saying you must set password before executing this statement, because I have set the password in your table, MySQL user table. I have done that, but
Okay.
this is the first time using the password I made a connection to your database, to
Sure.
your server. To your server, this is the first time I made a connection. After making a connection, immediately you have to give one more command, that is set password command. Then only your password will be like permanently set. Okay,
Oh,
always
okay.
when you are doing a bounce back in your database, when you're shutting down your server and you're restarting, it is not required for you to always go and set your password there. So you have to give this command set password.
This is the only time you do is when you change your password.
Change the password, yes, only
Not
when you're changing the password, and this is
not
a
when
one
you
time.
restart the server.
No,
Okay.
set password equal to
MySQL
MySQL
123
sorry, set password equal to
password.
password, and whatever the
One.
password we have, that is MySQL 123. That's
Correct.
all. Okay, so now my password is set here. Now just quickly do a restart of your server again. MySQL service MySQL stop,
And restart again.
and then start your server. And now your password is permanently saved. You don't need to go and change your password every time you are
It would not ask
logging
you
into
again
your
for the password.
okay. No, it will ask you for the password there, but MySQL
No,
1, 2,
once you
3,
logged
you have to
in.
always provide the password. But
Yeah, when you at the
yes,
MySQL
any
prompt, you would
database
not
I'm
ask.
connecting, yeah. For connecting to your MySQL prompt, it will prompt you for the password. With password
Correct.
only you need to make a connection. But now you are able to connect to any database, anything you can perform now. Now it's like permanently your root password is set here. Either
Correct.
now you are restarting your server also, shutting down and starting also, no problem. Nothing will happen. Now your password is permanently set. These are the
Okay.
steps you need to follow when you're doing for the first time fresh installation, or anytime you want to reset your root password, also same steps you have to do. What we have done there, first we have stopped your MySQL server and started your server in safe mode. We skipped grant tables option. Then we went and
Set the
updated
password.
the root user password in user table of MySQL database.
Yep.
In user table of MySQL database, we updated the root password. Then we just made a connection with this root user password, but we were unable to connect to any of the database there. So we have used the command set password command there. Set password command. Now you are able to, now your root user password is permanently set. Okay.
Correct.
So this way our RPM installation is perfectly done there. Okay, so my
Okay.
databases we'll see here. First of all, show databases. So I have shown you one database, that is MySQL database. In this MySQL database, you have databases information, tables information, users information you are having. Okay, privileges information also something you are having there. Now we'll see what is there in your information schema database. So if I say I want to see what is there in this information schema, so
So,
basically name itself says that it is having some kind of information.
so MySQL database is more like a system table spaces in the
You're right.
Oracle.
You're right.
Okay.
All are system table spaces only here, because these are all only defining the information.
Right.
Metadata is there in all the, but different data is available in different databases here.
Correct.
Like information schema, it is having more kind of information about your
Performance,
database. Like it is having information about your character sets. Okay, so
column,
what kind
column
of
query.
character sets you are having? Like in MySQL, the default character set is Latin 1. Okay, maybe
Right.
the first time you are hearing about this character set Latin 1. Like
Correct.
in Oracle, we have a Unicode character set, UTF-8.
Yes.
Okay, UTF-8 or Unicode character set. In MySQL also we have this kind of character set, but MySQL actually is supporting more character sets there. Okay, and the default is Latin 1. If you want to change the default character set, you can change it and make it as Unicode character set also. Okay, so let me just show you the describe character
Character set.
sets table.
Yes. You selected a line in.
Yeah,
There you go.
describe character sets, and you can see it over here. Select character set name and default
Okay.
collation. That is enough from character sets.
Yep.
And you can see it's supporting around 40 character sets all over the complete world, whatever the character sets are available. So everything. So you are having UTF-8 is also supported, but this is not the default. Like in Oracle, that is the default when we work with
Correct.
Oracle. Okay, but here it is not the default. Latin 1 is a character set. Okay, because this MySQL was actually
Swedish.
established by Swedish company. The company name was MySQL AB. MySQL
Correct.
AB was a Swedish company which has actually written this MySQL code and developed this MySQL database. So they have made this Latin 1 as your default character set. Okay, but if according to your environment, if you want to change any of the character set to Korean, Swedish, English, or your Unicode character set, you can change it. Okay, the parameter as a
Okay.
variable you can change it. We'll see later on how to change your variables. So here again, show tables. So these are the different character sets. Now what are the different tables we are having? Columns, collations are your
basically your character kind of thing only, like how you are going to write down your data into your database. Okay. And column privileges, engines you can see here. What are the engines? Like from the day one, I'm saying MySQL allows you to have different types of storage engines. Okay, so I'll just say describe engines. So you can see here what are the different engines available. Select engine,
support.
engines table. Okay, so it's a transactional support or non-transactional support that is also available here. So let me just show you only the engine's name, So you can see you
9
are
different
having around
engines.
9 engines in MySQL. So out of that, InnoDB, we were talking a lot about InnoDB engine, which is a default engine right now. Then we have got MySAM engine. These two are very popular and mostly used engine in MySQL, MySAM and InnoDB. But other than that, we are having CSV.
This engine is already installed. MySAM. InnoDB,
Yes, they are already
installed.
They are already present. They are installed and they are already present. But InnoDB is the default.
Correct.
Okay. So merge engine, black hole engine, memory, performance schema. Performance schema is a database name and it's also an engine name also.
Right. It's kind of confusing.
And federated engine. So we have got a lot of engines. So in your next classes, we'll see how to create tables in different engines.
Okay.
With different engines, how do you go and create your tables and how to see what are the files created with different
and what
engines.
is the and we're also going to see which engine is used for what purpose, right?
Yes, for what purpose? Yes. Which engine at what point, like what is a situations sequence we need to have, what kind of engine can be used in which kind of scenario.
Scenario and application purpose, right?
Yeah. Cool, so these are the engines that we are having. Now like this, we are having information it is giving you. Basically, information schema is giving you information about your character sets, engines. Tomorrow, if you go and create partitions, how many partitions are present, profiles, like it will give you the information about what kind of profiling you're doing to your database. Profiling is basically you can see how your query execution is happening. Your plans and all.
Profile for the execution plan.
Yeah, plans and all, your query execution and all, you can actually see. Process list, this table will give you the information about the number of processes that are joined. User processes information, it will give you the information. Like how many users are connected to the server and what they are doing exactly and all, you can see it from your process list. And you can see session information, table privileges, and if you're using PLSQL objects and all, triggers, queues and all you can have. And InnoDB information also, like InnoDB is the default engine. So InnoDB is columns. Lot of tables are there which we actually have not used when we have worked for so many years. Also, maybe we have not even encountered these many tables, because a lot of data dictionary metadata tables are available. So according to the scenario or according to the situation, we'll be going and using the table. So I'll be showing you what are the frequently used tables that are there in every database. Then we'll see what are the different
day-to-day use.
Yeah, frequently what are the tables that we are going to use there. So again, now next database is your performance schema database.
Yep.
Use performance schema. Now my database is changed. Show tables. Basically, this database is also again introduced from 5.6 onwards. Again from 5.6, basically a lot of new changes have come up. Like in Oracle also, earlier we used to have only system table space. Then they have introduced that SysOx. SysOx was basically to store your performance reports and all, huge performance reports and all. Same way here also in MySQL. Earlier everything was there in information schema only, but it was getting difficult to manage huge information about your performance related thing there. So now they have come up with a new database called as performance schema database. So all your performance related information is stored here. Okay, events information.
So for the performance, Yeah, for any performance issue, we need to come to this
Yes,
database
we
to
can check here,
do the
like
troubleshooting.
events, weights history, like what are the different types of weights happening right now, weight summary, weights history, instances, mutexes are logs. Mutexes are nothing but your logs that are held there. So like these, any kind of performance issues you are having, and you want to know about your performance related information, you can go and check this performance schema database. Okay. Then
Okay.
lastly, we are having the test database. Test is actually a kind of test database. It's a random sample database, I can just say. It is not
Kind
at
of
all
like a
having
Scott
any
schema.
tables. No tables are available. It's just a sample database that
Okay.
is given. Any kind of testing or temporary tables you want to keep for some duration, you
Sure.
can just go and create your tables and you can work with that. Okay.
Got it.
So these are the default 4 databases that are available in MySQL. When you just install your MySQL, you'll get these 4 default databases. MySQL is actually a very important database because it's having the databases information and users information.
Right.
Okay.
And
And
privileges.
information schema basically about your character sets and all, about your privileges and on all performance schema and performance related information. Okay,
Got it.
so these are the default databases we have seen. Next is, we at the time of installation, after installing, we have seen that when we really want to see where all my files are located, it has given us the default directory as varlib MySQL.
Varlib
Okay,
MySQL.
so
Okay.
now let me log in into varlib MySQL and see what exactly is there in this varlib MySQL. So whenever we do the RPM installation, you get a file by name auto.cnf. It's a connection file only. CNF is your connection file. An automatic connection file is generated. And this is a new file that has come up only with your RPM installation. Like in binary installation, we have not seen this auto CNF file anywhere.
I
Okay,
see.
this is a connection file only, like automatically this file is generated a connection file, and IP data, IP log file, these 3 files are there for your InnoDB. InnoDB has 1 data file by default
Yep.
and 2 log files.
Okay.
Okay, so in tomorrow's class, when we discuss in detail about your storage engines, we'll see what is your IP
Sure.
data holding and what is your log files holding here. And it is giving us a directory with your database names also will be, your databases also will be created as your directory. So MySQL is a database here.
Yep. So
Performance
my
schema is a database.
and
Okay,
test.
so that's 2 databases, and test is also a database.
For
Information.
InnoDB, they don't have the directory.
Sorry, no, these are the databases directories actually. MySQL
Yes,
directory.
but for the
Information
InnoDB,
schema, you're saying.
yes. Okay. Got it. Got it.
For information schema, you're not having any database directory over here, and you have got an error file, a process ID file. This is generated every time you start up your server. MySQL server is started, a PID file is generated, and in addition to this,
Yep.
you will be getting one socket file also. Socket file is also a
Yeah,
connection file. A connection file that is
OCI.
generated.
Okay.
Socket file, mysql.sock. It is also a connection file. Basically, when your MySQL is started, MySQL will actually open a socket for you, so that whenever a client comes in, he can make a connection into that socket. Like it's like you are plugging in your client's machine into this socket, and immediately a connection is
Okay.
established there. Okay, so that is the work of your socket file, and this socket file is also generated when your server is running. When your server is down, this socket file is lost.
Okay.
Okay, so RPM upgrade history and all this, at least any kind of upgrade you are performing, any RPM upgrade is happening, that will take care of. So these are the default files that are available in your varlib MySQL directory. Okay, so this is your default location, and where is our configuration file located? It is there in my.cnf USR location. So my.cnf.
CNF.
So you can see again a default, some random default configuration file is available. So you can go and change these values there. So as the
Okay.
classes goes on, I'll be going on adding the parameters in this configuration file. We can have a customized configuration file, and we can just go
Sure.
and generate your databases later on. So this is some default file
Correct.
it has got here. Okay, so this
Got
is
it.
basically your RPM installation. So your RPM installation, we just installed some 5 or 6 RPMs I have installed, and your MySQL default databases got created there, and we went and started your MySQL server, but we need to set the root password. So we connected to MySQL database user table and we updated the root password, but it is not permanent. So we have to go and restart your server and make it permanent by using the set password command. So then your root password becomes permanent. After that, we are able to log in into your server, and like I just want to shut down your MySQL server, you can just simply say service MySQL stop. That's all. There is no need of giving shutdown command there. Just say service MySQL start and service MySQL stop. That's all.
Okay.
So it
Yeah.
is one command for starting and stopping your MySQL server. I just want to start it.
All
Just
right.
say
Same
stop
command.
and start. Same command. And for logging into your MySQL server, we are using this utility, MySQL utility. This is your
All
client
right.
utility, MySQL client utility.
Same for the both binary or the
Oh, yeah.
RPM.
But for binary, we always have to be in bin directory for making this connection.
Correct.
Bin
Right.
directory. But here it's not required. Just simply say MySQL -u root -p. You are able to connect. Okay.
Correct.
So now let's go and create certain tables here. Okay.
Okay.
So what is a if you want to see engines information, I can just see show engines also. I can see. So one
Okay.
thing is I can go and see the engines information from your engines table also. I can see that was there in your information schema. Engines table was there, right? So
Correct.
here I can just give a command like show engines. If I say you can see engines information here also.
My
So you can
same
see here my SAM engine support is available. Transactions, no transaction support. Okay, like this. You can see here, how can I say InnoDB is a default here, because it is giving us
Oh,
that
I see. Okay.
InnoDB is
Yep.
a default engine and it supports your transactions and it has row level locking. It is same like your Oracle. If you are
Right.
working MySQL with InnoDB engine, it is same like your Oracle tables and all. Supports transactions, row level locking and all we are having. Only InnoDB engine is the transactional support engine. All other 8 engines are non-transactional support engines. Which means if you are doing any changes in any other engine table, they are not permanent. You can perform the changes. It's not like they are read-only kind of thing. You can do the changes, but those changes are temporary available. Okay, but they are not permanent. Once your server instance got crashed or something, you don't have a guarantee that you will be getting back your data.
Got it.
Okay, that is your non-transactional support engine. All other engines are non-transactional support only. Only InnoDB is the transactional support engine.
So if you were to
Okay.
use InnoDB in a database crash, you will be able to recover those transactions
Yes, you will be able to recover those
from the log file.
Yes.
Okay, we will see
Because
that.
InnoDB only has a default log files also, IP log file 0 and IP log file 1.
Correct.
No other engine will have any kind of log file also. No other
So,
engine will have any kind of log file. Only
so we cannot even.
InnoDB has the log files.
Okay, so we cannot even add log file to any other engine.
No, we cannot add them.
Okay, just by default is InnoDB for transaction purpose.
Default is only the InnoDB only having the log files there. Okay,
Got
so
it.
now let me go and create a new database. Like default databases are there. We can
Yep.
actually go and work with your default databases also. You can go and create your own tables in default databases also.
Sure.
Like in Oracle also, like system table space also, you can go and keep your tables, right? System table space also, you can keep your tables, but it is not recommended to use your normal tables in your default
Application.
databases,
Correct.
right? So it's recommended you go and create your own databases there. So how to create a new database there? Just give the command create database student.
Student.
That's all.
Okay.
the database is created. You can see how simple it is. Same thing if you would have done in Oracle, what are the steps you'll be having? Either if you're doing manually, first go and set up in your P file, give the parameters and all, then start up in mount state, no mount state, and give lot of scripts and all you have to run there. Or if
Yep.
you're using DBA also, then a lot of multiple steps will be there, then a new database will be created. Okay, so
Correct.
Oracle is basically a very structured database, very lot of
Systematic
background
database.
processes are involved and a lot of steps are there. But here in MySQL, simple one database I want to create, just say create database student, that's all. Now I just wanted to see that what is the default character set it has picked up, because my database got created, so thus there should be some character set it might be holding, right?
Correct.
So you can just give the command as a show create database student. I just wanted to see how this database got created. So you can give the command as show create database student. It will give you what things it has used to for creation of your database. So it has created create database student it has given, and what default character set it has picked up, Latin one.
Right. What
So
is the
whatever
40?
the tables you create now, those it's
What's
actually
that
the
number?
database ID.
Oh,
This is
database
actually
ID.
the no, sorry, it's not the database ID. It is the version number from starting from your 5. Basically, some version number it is giving you. So this is the database version number that it has given.
Okay. Now, does this have a database ID somewhere or no? Just
No, database ID is not present there. Here, we are not having any kind of database ID there.
Okay.
It is just the version number. So 4.0.1.000. So from MySQL 4, basically this database creation has been taken like this. Below that version 4, it was a different way of creation of your database. Different command was there.
Sure.
Okay. So this is your database. Now let me see if your database is added in your list there. Show databases. So yes, I have got a new database by name student.
Okay.
Now let me connect to the student database. Just use student. I am able to connect to the student database. You can see here, select database, and you can see, yes, I'm connected to student database. Now you can go and create your own tables, because I don't have any tables right now. It's just an empty database. You can go and create tables. So simple SQL way of creation of your tables. Create table name. I'll say table 1. Create table name. C1 column 1 integer I'll take, and column 2 some character of 10. Okay. And just close here, semicolon. Now your table got created. Okay. Did I mention in which engine this table will be created and all? Nothing I have done. I just went and created a normal simple table I have created. Create table name and column names and your data types and all. Now let me see in which engine this table is created basically. So again, you can just say show create table 1. So it will actually
table
doesn't exist. Let's show create. Okay, table spelling. I have actually given a wrong table name here. That's why it was given to you.
Okay, got it.
Table 1.
Got it. Yep. Show create table table.
Yeah.
Okay, now
so here now you can see the column names, integer, data types and all. Engine, you can see it is using your InnoDB engine and default characters. Because I have not mentioned which engine it will be created. Your default engine is InnoDB engine. Okay, so it will go into the default engine there. Table will be created in your default engine, that is your InnoDB engine. Okay, now let me just insert some data into this table. Insert into table 1 values, column integer, and some name, some character I have just inserted. Okay, there is no need of committing here in MySQL, because in MySQL, even if you're doing DML operations, you are having auto commit option there. Okay, but if you
But if
feel
you
that,
want to roll back.
yes, if you feel that what happens if I have given a wrong statement or something, okay, so you can go and remove that auto commit parameter, and you can just make it as a, every time I am doing a single transaction, I have to commit it manually. Then you can just go and roll back there.
Okay.
Okay, so it's your choice. Okay, so now if I just go and see that I have inserted one record there,
Select
so
star from
select star from
table 1.
table
Yes.
1, so one
John.
record and one row inset. It in form of table also it is giving you, in the
Yes.
form of table, and the query execution time also it is giving you. MySQL execution time, or your execution of your query, is very fast.
Now the
Okay,
time
it
it
takes,
shows. Okay, the time that shows 0.00 second is the execution time or the time that to fetch the data.
it is actually the complete query execution time, the
Oh,
complete
okay.
time it has taken for your execution of your query. Again,
As soon as you
in
file the
your
query
performance
and
classes, I'll
return.
show you, like we can actually see the time that it has taken to enter into the server. We can see the time it
Yes.
has taken to process the query and generate a plan, then the time it has taken to go and fetch the data, then the time it
And
has taken to write the data, read the data from your files, data files, and then give it to the back to your user. So the complete timing we can actually divide. Okay,
segregate them
yeah,
into the.
segregated times we can see in your
Okay. We'll see later.
files there. Okay, so that is, but that time is also in microseconds. Okay,
Yes.
basically I want to say, like in Oracle, it will take, when I just
Few
compare
seconds.
MySQL with your Oracle takes more time for your query
Select.
execution compared
Yes.
to your mind, because Oracle has background processes. Each background process it has to invoke, and that background process will go and do its work.
Correct.
Okay, it's like it is dependent on the processes there, but MySQL is not like that. MySQL, lot of things are linked with each other, and whenever it wants to fetch the data, it just simply, the process will go and read the data, it will throw the data. So there are no background processes which need to be invoked, and there are no lot of steps that we need to required there. So MySQL query execution is very faster when compared to your MySQL Oracle. Okay, very rarely you find that 1 second it has taken, or 2 seconds it has taken, like huge amounts of table, like terabytes of table you are having, then you will see that your table execution time, it will go for 1 second or 2 seconds there. Okay, but mostly it will be in micro or milliseconds only, the time duration.
Okay.
So
Yeah.
now I have created an INODB ingest table. Now let me just go and see the file system here. So when I
Yes.
just say var name MySQL here, and
We have
let
student
me go
folder.
here. So yes, I have got a student database here. So go to your student database, and you can see here I've got 3 files. Anyway, student, for because I've created a database, like an optional file is created for a DB database. Then 2 files have been generated for your table, one that is .frm and .ipt. Okay,
Okay.
so
What's
basically this FRM file is your format file or your structure file. Okay,
structure of the
the
table?
structure of the table is actually stored here in this one, and IPD, your complete data is stored here.
So
Your data is stored in your IPD
the
file,
okay.
and your FRM, it is a structure file. Then this is for your INODB. Then what is this IP data one holding here then? Earlier also we used to have this IP data one. If I can just scroll up.
Yeah.
Before creating the database also, before creating the table and all, I had this IP data one, and you can see the size here, 2912 something. Okay, so the same size is available here of IP data one. It has not even
Yes.
changed also. a slight change is also not occurred here. So why this data table is available? This file is available here. Actually, earlier to 5.6, again earlier to 5.6 till 5.5, whatever the tables you were creating in InnoDB, all those table information, the structure information and data was stored in IP data file only.
Okay.
Okay.
Now is the
But
individual file.
yeah, individual files. What was happening there? Because suppose in a database I'm keeping InnoDB tables, will create lakhs of tables or thousands of tables we used to create. All those tables were going to your IP data. So this data file was becoming very, very huge. Okay. And
Then
because of
we are
that, we were
IO.
getting a lot of IO and performance issues. Like reading the data
Correct.
from a bigger data file always takes time.
Right.
Okay.
And then you
Till
have multiple
5.
connection coming in.
Yes, till 5.5, we were facing lot of performance issues with your MySQL server if your database size were very huge. Okay, lot of InnoDB tables are there, then this IP data file was growing hugely in size, and your IP data is not required, like you don't face any kind of space issues because it is auto extensible. Okay, by default it is auto extensible, so size issues we would not get. It would be increasing the number of the size of your hard disk. If space is available, it would increase, but the
So
size was becoming very, very huge there.
so IB data one, the data file, will have like a metadata information for the each of the database or table, some kind.
No,
What is
the
it?
earlier to 5.6, it was storing the metadata and the data also.
Okay.
So there was
Now,
not a separate file. There was no separate data file here for every table there. So all your InnoDB tables, data and metadata would be stored in IP data only till 5.5. But from 5.6, what they have done, they are just storing the metadata in IP data now, and your actual data is stored in your IP data, IPD file.
that's what I mean. I mean, it stores the database name and what
Yes,
that database name
correct.
has, what tables.
Yes, that only metadata will be there in your IP data file now. Now your actual data is kept in your IPD file.
Yeah. Okay. Then when query
So
file go to
every table will get its
InnoDB.
own. Yeah, now I have just created one table one. Now if I go and create a next table, table 2 if I create, so table 2 also will get a FRM file and one IPD file. So
Got
every
it.
table will have its own structure file, every table will have its own data file.
And if we create an index, we'll have an index file different.
Index also, no, for index you don't have any other separate file here for InnoDB. Indexes
Oh,
information also will go in this IBD file
okay.
if you're creating any
Got it.
indexes also. You don't have any
Got it.
separate file there. For
Oh, okay.
MySam, you
Got
are having a separate index. This was a good question because when we see for MySam has a different file for indexes. But
it.
for
Okay.
InnoDB, your indexes and data files both are stored, information is stored in one single file, that is IPD file. Okay, so
Got it.
why this has, how this has been, how it is actually creating a separate file for each and every table there because of one parameter there. So in MySQL, we are actually having a parameter MySQL -u root -p. So we are having
MySQL.
MySQL 1 to 3. Okay,
Correct.
so whenever I want to see any variable, so in MySQL we call it as
Show variable.
show variables like percentile,
And
uh,
abbreviate.
InnoDB files. I don't remember the exact
Sure.
parameter. Then you can give percentile. Then it will give you the parameters that are related with this one.
Sure.
InnoDB files per table. I think it's
Maybe
5 per table. file it is, and show variables like INODB file. You can see here there is a parameter INODB file per table that is on.
Okay.
So this parameter was available from 5 MySQL 5 onwards. This parameter was available, but it was off. So because it was off, every table data was going in IB data file mode. And because of that, your table that data file was increasing huge in size. But later on, they discovered that this is the parameter. If we change it, then every INODB will generate each table for every table. It will generate a new data file there. Okay, so this parameter is by default turned on from 5.6 onwards by default.
Got it.
INODB
So,
file.
okay, and we don't need to add any extra data file or anything like that for the tables or database, correct? On this
No,
MySQL.
not required. So suppose if your this data file, that's what I'm saying, auto extensible. The
Right.
sizes
Okay.
of in MySQL, all your data file sizes and all are auto extensible. Like if your data file is filling up or something, you don't need to go and increase the
Oh,
size
it's all right. It's
and all.
all
It's
depend
not
on
required.
your OS level, disk size.
Level, yeah, it depends upon your disk space and all. If you are having
Right.
space, then you
No
just
issue.
need to monitor the disk space then.
Got
Sufficient
it.
space if you are having, then that's all. They will be automatically extending as the data is going on increasing.
Okay.
Okay,
Got it.
so this is regarding your INODB. Again, in INODB, we'll see in your tomorrow's class, we'll see INODB features. Like now, INODB is our first storage engine. So from tomorrow, we'll start what are your storage engines and what are its features. And anyway, we have seen the file system of INODB right now, and INODB has two more log files also, IP log file 0 and IP log file 1. 2 because when it is writing to the first one, first it writes to the first log file, then it goes to the second. Then
So,
after that, it will come back and write it to the first log file. So here, one thing here, it is not archived. Like in Oracle, we have two log files, like one file, it is writing, second file is archived, right? So
yeah,
you
it's
can have
switch.
your data. Yeah,
Yeah.
you can have
Here
your
it doesn't
data. But
switch.
here, it's not archiving, actually it is overwriting.
It's kind of like a mirror copy, is it? Hello? Can you hear me? Hello?
This conference will now be recorded.
Okay, so last class we have completed MySQL installation. So we have done binary installation and then RPM installation. So right now in my server, I'm having RPM installation where all your files, data files and log files are there in valid MySQL directory. Configuration file is there in USR location, my.cnf. Okay, and I have 4 default databases. Then we have last class we have created a new database also by name student, and I have created certain table with InnoDB engine, the default engine, and we have seen the file system of InnoDB engine also. That is, it has a .frm file and .ibd file, right? So let me just take a notepad here and we'll show you what engines we are going to discuss right now. So today we are going to see about the storage engines. Storage engines are the structures that tell you how to go and store your data in MySQL database. Okay, in MySQL server, how you're going to store your data. Either you want to store your data permanently or temporarily, you want to store the data in memory or in a remote server. So different options are available. Like you can have your data in memory also, or you can have data in a remote server also, or you can have data in a remote file also. Okay, so different options are available, so we'll see that all today. So the first engine, the most popular engine and the default engine is InnoDB engine. Okay, and InnoDB engine, it's a transactional support engine. Transaction, and this is the only engine with transaction support. All other engines are non-transactional support engines only. It's a transactional support engine. Next thing, it has a row level locking. Has a row level locking. So we'll discuss about different types of lockings in next classes, but just understand that row level locking means what? When in like in Oracle, like if a user is trying to access a particular row, he's doing some changes on that particular row, that row will be locked unless and until that user commits that row. That row is not a that row is not accessible to be changed by any other user. Okay, so for readability purpose, the other user can go and select and read that row data, but he cannot modify the data unless and until the first user goes and commit the data. Okay, so that is row level locking, which is similar to your Oracle. And what kind of files we had there in InnoDB engine? We have got one .frm file and .ibd file, so where your structure and your data are being stored. And in addition to this, we have got a IB data and IB log file 0 and IB log file 1. So yesterday I was discussing that in log files for your InnoDB. Let me first start your MySQL server here, service MySQL start. Okay, so my InnoDB files are there in valid MySQL directory. So I was talking about IB log files yesterday, that 2 log files you will be having, IB log file 0 and log file 1. Some default sizes of around 49 MB size, something your files will be having 49 to 50 MB size it is given. So here, whatever the changes, whatever the transactions you are going to give in your MySQL server, everything is recorded in these 2 files. Okay, but it's not like in Oracle. Like in Oracle, what happens when it is writing to the first file? First, it writes to the first file, log writer. Then it goes and writes to the second file. When it is writing to the second file, the first file gets archived. Then when your second file, again a log switch happens, come back to your first file, then second file gets archived. Like this, you will have lot of archive log files there where all your data is being stored. And these data can be used in recovery. Like tomorrow, if you are having any issues or something and you want to restore and recover your data, for recovery, these archive log files can be used. But in MySQL, it is not like that. In MySQL, your two log files. When first it is written to the first log file, that is log file 0, then it will go and write to your, the process will go and write to your second log file. When it is writing to the second log file, the first log file will be overwritten. Okay, so when again coming back to your first log file, the first log file will be overwritten. So your data is not actually transferred to any other file there. Okay, so these log files are just for recording the ongoing changes, that's all. Okay, then you can have a query, what happens if I want to recover my data tomorrow? I just wanted to have a file where all my data will be recorded, and tomorrow if we want to do any kind of recovery, okay, so that recovery also should be possible there. So for that thing, we have got a special types of file in MySQL, that is binary log files. Okay, so in logs class, I'll discuss more about these log files and all. We have different types of log files in MySQL. So basically, binary log files records all the ongoing changes that are happening in your MySQL server. And not only the InnoDB changes, it also records your MySAM or any other database, whatever the changes you are doing, everything gets recorded in your binary log files. And tomorrow, if you want to do any kind of recovery, binary log files are similar to your ARCHI log files. Using binary log files, you can restore and recover your data. Okay, so these log files here, they are just for recording the information, and simple log files for monitoring, that's all. But these log files will not be able to go and from these log files you are not going to go and generate new types of recovery files. Fine, so these three are the files for your InnoDB engine. So we in your practical document that I have shared, we have got lot of information about these engines. Okay, so show engines we have already seen yesterday. Show engines will give you what are the engines available, and are they transactional support, non-transactional support, and all those things, and which version they are supported or not. Okay, certain engines, they are not supported in 5.6, or they are not available. They are not by default enabled. Supported in the sense they are not enabled in certain versions there. Okay, so you can just check that thing. Then you can actually change the default storage engine also. Okay, like you can give the command set default storage engine equal to archive. I've set default storage engine equal to, like right now the default storage engine is InnoDB, but tomorrow if you have a requirement that your default storage engine has to be MySAM, then just say set the parameter name, that is default storage engine, and change the engine there. Okay, so I'm not changing here because again a restart of your server is required after I change the storage engine there.
Question.
Okay, restart of your MySQL instance. Yeah.
So who can change the storage engine? Is the DBA or the application?
Root.
Root
No,
user.
the MySQL DB only can change the storage engine.
Mean root user.
Root user. The root user or the MySQL DBA. He
Yeah.
is only
Okay.
handling the MySQL
So
server. So he will
whoever
only
has a
change.
root password can only change that.
Yes. Yes.
Okay.
You're right. Okay,
Got
the
it.
first engine is InnoDB storage engine. Okay, as of MySQL 5.5 to 5.6, this is the default storage engine. So these are the features of your InnoDB. What are those? Storage limits up to 64 TB. Okay, up to 64 TB means maximum to maximum you can have up to 64 TB size of your database. Okay, it is same for
Okay.
InnoDB, and this is for 5.5. Again, from 5.6, this limit has been increased. 5.7, they have gone up to 100 TB or something, and in 8 they have gone to so much of huge size.
Okay.
Okay, so with every
So
version, the size of your database storage is increasing.
is that per table, right?
Yes,
64
yes,
terabyte per table.
for table, yes.
Yeah. Okay. Not the database.
And not the database. And transactions, yes, it's a full transactional support engine. Locking granularity, yes, locking is available, and that too we are having row level locking.
Okay.
And MVCC control, MVCC is multi-version concurrency control. Like are your users able to concurrently access the data on a same particular row? Yes, because people like tables having row level locking, then they can actually concurrently go and access the multiple rows. Like one user is accessing one row, only that row is locked, right? So other
Correct.
users can go and access other rows in the table. So concurrently they are able to access a single table. Parallelly they are able to access a single table. Why this MVCC has come up? Because later on you'll come to know that we'll have a table level locking also. Table level means like if a user is accessing a particular row in a table, the whole table will be locked. If a table is locked, if one user is working on that particular table, other users cannot go and access that particular table. Okay, so table level lockings are actually very, very critical, because table level locking, if you do concurrently, the users cannot go and access the data. But with
Okay.
my row level locking, MVCC is possible, and geospatial data types support. Geospatial means on Earth, whatever the data types are available, all your data types are supported by INODB. Like either you take your integer, character, uh, large objects, blobs, clobs, whatever the data types you are having, every data type is supported by this INODB engine. Indexes are also supported, all your indexes, either you take B-tree, what you call the bitmap, okay,
Full
and
text.
the function indexes, any type of indexes, B-tree indexes, T-tree indexes. Hash indexes are not supported, like it has no support for your hash indexes.
Okay.
Okay, full text search indexes are supported, clustered indexes, data caches are supported, index
What is the
caches
full
are there.
text mean? What is the full
Full
text?
text search
Yeah.
this one, full text
Yeah.
search indexes you are saying.
Oh,
So
yeah.
I have not worked with this type of indexes. Maybe it might be a type of index where um, your indexes will try to get your data completely. I really don't know about this because we have never used this type of indexes, but this might be existing. I'll just try to know what exactly this mean and will let you.
Okay. Thank you.
Okay, then index caches are supported. You can compress the data in INODB tables. You can encrypt the data of INODB tables. Compression, encryption is available. Cluster database support is not available for INODB engine tables. This is one critical thing. Actually, no other engines tables are supported for a cluster database. Cluster database means what? Like only single instance you'll be working with this kind of engines. But if I go in clustering you have something called as NDB cluster, and different types of clusters are there. There actually how you're storing the data will be changing in clusters. Okay, so this is something different in MySQL. Like in Oracle, clusters means what? Like whatever we have learned in your standalone, that is just an
Similar.
extension of, yeah, similar will be
Yeah.
there. And in clusters, it will be just an extension. But in MySQL, it is not like that.
I
Okay,
see.
your clusters, when you're working with your cluster databases, you cannot have your INODB tables there. Okay, some other types of engines are available for cluster, like special type of engines. Okay,
Okay.
then replication support is available. We'll be seeing in your coming classes how to replicate your data, that is master, slave and all. There you can
Okay.
have INODB tables which can be replicated. Foreign keys supported. You can have point in time recovery using INODB tables. Query caches support is available, like which means if you are accessing a particular output, that output you can have it on your cache.
Okay.
Okay, a copy of your output can be kept in your cache and will be given back to the user, so that second time the same query is coming in, you can access the same query from your query cache instead of going and reading it from your files. Okay,
Right.
so that
Now,
will improve the performance there.
backup and point in time recovery, we're going to do that performance, right? And the
Yes,
backup
yes.
and the,
I'll show you.
okay.
I'll show you point in time recovery in detail in your backup classes. We'll do a
Yeah.
point in time recovery using INODB tables also we can perform. Okay,
Perfect.
so and update statistics for every change you are doing. Your statistics are updated in your all your data dictionary. Okay, all your data dictionary tables, your statistics get updated automatically.
Okay.
Okay, so these are the features we are having. Certain features they have given. Again, advantages of using InnoDB engine. A lot of theories available. You can read these things like it's DML row level locking. It supports InnoDB supports foreign key. Same thing it is given there.
Sure.
And creating InnoDB tables. We have already created a table. Foreign key limitations of InnoDB. There are certain limitations also, like maximum of 1017 columns are allowed in a table. Like these are all
Okay.
your theoretical values actually, and 64 indexes are allowed in a table, secondary indexes. Like by default, you'll have one primary index.
Right.
Okay, every table by default it will have one index there. In addition to that, 64 secondary indexes are allowed in a table there. Okay. And like this, you are having a lot of theory values like blob and text um, data types are also supported there. The next type of engine is your MySAM storage engine. So mostly you have to concentrate every engine that it's a transactional support or not, what type of locking it is having, what kind of file system it is having, what kind of files it is holding. Okay. Then
Mm-hmm.
now second type of engine is MySAM engine. MySAM engine, it's a non-transactional support engine. It's a
Transaction support.
non-transaction support engine,
It's only select
and it
only.
has table level locking. Yes, only select. Even if you try to do, you can do changes, like you can do changes, but those changes are not guaranteed. Okay, they
Mm-hmm.
might be available or they might not be available, like that. So for that thing, generally we don't do the changes also, because MySAM doesn't have log files also. Okay, and
Mm-hmm.
those changes if you are doing also, they are not recorded anywhere. So mostly we'll try to perform your select operations, and it's kind of read-only environment only we'll try to use this kind of engine. When you
Okay.
have a lot of reads happening on a database, so this MySAM engine is used in that scenario.
Now,
And it
how would
has a
you load the data in? You load it through.
table level locking. It is loaded through at the development stage only.
Okay,
Like your
that's right.
developers will be just loading the data at a time. Like in Google, like your developers will be loading, like Google is internally using MySQL, MySAM engine there. So
So
they load huge amount
you
of
can
data
load up one time.
one time. Yes. One time you can load, and internally, like you want to do the changes, you can do at one time. That's all.
You can update one time then.
You can update also. But end users, they are not allowed to change any data. End users, you are not as a client.
Back end, you can do whatever you want.
Yes, backend, whatever you want, you can do.
Got it. Got it. It's only end user is only read only.
Read-only
But
environment for
right.
end user. Yes.
But the back end development or DBA can update and delete whatever we need to do.
Yes. Yes.
Okay.
It
That's
has a
clear.
table level locking here for MySAM engine. So we'll see the features again here. Storage limits have been increased a lot. Like it
Yeah.
is 4 times more than your InnoDB engine storage.
Right.
Okay, huge amounts of data you can store in MySAM engine. Transactional support, no. Locking granularity, it is saying no because it is considering only row level locking here. But actually, your MySAM has something called as table level locking, which means one user is accessing a particular record, the other user cannot go and access that record. Okay, like one session. Okay. MVCC, that is what your MVCC is not available there. That concurrent access is not available there.
So two end user
Geospatial,
cannot.
yeah.
Okay.
Data type support, index type supports, and all your indexes, caches, and you can encrypt the data. You can compress the data. Cluster database support again not available for this engine. Replication support is available. point-in-time recovery you can perform, query cache support you can do, and the statistics are updated in your data dictionary. So what kind of files are generated when you create a MySAM table there? Okay, so let me create a table here. I'll just copy it from here.
Yeah.
Okay, so let me connect to the MySQL server -u root -p. I'm connected. Now connect to the student database.
Huge student database.
Use student. I'm connected to student database. Now just right click on your mouse, if anything get pasted in your putty session. So I'm creating a table, create table, table name, column 1, column 2. If I don't explicitly mention here engine, then
You go
what
to
happens? Your
IMDb
table gets created in InnoDB. But
by
now
default.
I want my table to be created in MySAM engine. So every time you want to change your engine and create in a new engine, the table, you have to explicitly define engine, which engine you want to create the table.
Which engine
Okay.
you want? Okay, got it.
Yes. So we have to mention engine equal to InnoDB. Then what happens? Your table now will be created in InnoDB engine. Sorry, in MySAM engine. Show create table 2. And you can see now your engine, now the table is created is MySAM engine.
All right.
Okay. Now you can insert the data because I'm a DBA, I'm not an end user here. I'm able to insert the data. I can modify the data, but the end user, the client cannot do that. For
Okay.
them, the transaction support engine is not available. So insert into table 2 values.
Okay, you have to write the values. Okay, that's what I was missing.
Values and some name. Okay, so I have got now some data here. Okay, so what kind of files are generated for your MySAM engine table? So go for student directory, and you can see that I have created a table 2. So table 2 has 3 types of files, that is FRM, MYD, and MYI. Okay, so FRM is your structure file. Okay,
Okay.
MYD is your data file where exactly your data is stored, and MYI is your index file where your index information is stored. So why
Okay.
we didn't put an index file for your InnoDB? InnoDB actually uses cluster indexes. What do you mean by clustered indexes? Clustered indexes are your data and your index information is stored in the same file. Okay, so that is actually your clustered indexes. Mixing, like this IBD file only will be holding your data information and index information also, both will be there in
Metadata
IBD
information.
file. Yeah. Then here for MySAM, it is not like that. Index in a separate file, data in a separate file.
Right. Okay.
Why they
So
have
index
given
data.
separate? Because yeah, because MySAM engine when we are using, the MySAM is can actually support huge amounts of data, like 4 times the size of your data can be held by your MySAM. And
Right.
most of the time MySAM, a lot of reading happens. When you are doing a lot of reading, indexes are mostly searched there when you are doing a lot of reading there.
Indexing, a lot of
Okay,
indexing.
faster access to your, yeah, a lot of indexing happens, a lot of faster access to your data happens there. So that's why they have just divided an indexes into a separate file and data into a separate file for MySAM.
Got it.
Okay, so what are the 3 types of files we are having for so like these, for every engine the files will be changing. Okay, you cannot restrict, like in Oracle we had a restriction like only data control and redo log files, that's all. But
Yeah,
in
it's only three
MySQL,
types of files.
yeah, 3 types of files. But in MySQL it is not like that. For InnoDB we just had 2 types of files, but now for MySAM again the extensions are also changing. It is .myd
And it's
and
also depends
.myi.
on, and these files are per table, not per the table space.
Yes, it's per table. For every table you'll get like that. Like if you are 100 tables, if you are having, then 100 files are generated.
100 times 3
So
though.
if you, yes, 100 times 3, like 300 files are generated then.
Right.
Okay, so that is your MySAM engine. And characteristics like theory, you can check like up to 64-bit length, large files are supported, maximum key length and all, blob and text columns can be indexed.
Sure.
Like these, like theoretical values are available. And you can, if there are any kind of corruption in MySAM tables, you can actually go and repair those corrupted records also in
We're gonna
MySAM.
perform that too, right? Corruption.
Yes.
Okay.
Repair of your corruptions are also possible in MySAM engine. Okay,
Okay.
InnoDB, anyway, it is possible. InnoDB is like more like your Oracle. InnoDB
Right,
is
because
more
you can
defined and all.
recover.
But MySAM also you can actually do, like if there are any corrupted tables, then you can repair those tables also in MySAM.
Okay.
Then next engine, third type of engine is memory engine. Memory engine, the name itself says that it is actually storing the data in your memory. And again, it's also a non-transactional support engine only.
Just for the performance.
Yes,
Okay.
for performance point of view, like if you want your data to be accessed very fastly, very quickly, I want to access my data, you can keep that data in memory.
Right.
Storage depends upon your RAM, how much of memory you are having, that much of data you can store. Okay, transactional support, no locking, no transaction, no MVCC. Data type and index support is available. And full text search indexes, no. Clustered indexes, no. Data caches are not available there again. And replication support is available. You cannot compress and you cannot encrypt the data also, because the data is in memory. It's not in physical file, so you cannot
Right.
compress that data also. And cluster database support is also not available there. Replication support is available there. So what scenarios we try to use your memory tables? So memory tables are mostly used when having non-critical data and session related things you are doing, because memory is available only for a particular session, right? And
Right.
once your server instance is down and all, the memory gets released there. So that kind of non-critical data, if you want to store, you can just store there. And when you want to have faster access to your data, because having the data in memory gives you fast access when compared to reading the data from your physical file. Physical file doing an IO, CPU time and all, it will take time. But
Correct.
memory, it is very much faster. So that kind of operations, temporary operations you want to perform, then you can have your tables in memory. Okay, so very rarely, these are all like a special type of engines. Like we cannot have a database with the default engine as memory. Very rarely. Like default engines, what we do, will have default engines as InnoDB or MySAM. Because if I make any engine as default and if I create any table, all your tables are created with that engine.
Just
okay,
for
so most
temporary
of the
purpose.
time, yeah, but memory engines and all, we cannot make them as default, because these are like for temporary purpose we are using, and that's all. We can just leave. Tomorrow, if something, your instance get crashed also, your memory gets released also, you're not much bothered, because that is not a very important.
Right. Or your session end.
Yes. So let me just try to create a table, and we'll see there what exactly are the files that are created in your memory engine table. And again, for memory engine also, the theoretical values are given, like how much of row size and all, it is supported there. So let me just connect to the server. Use student. Connected. Let me create a table here. Create table something. Memory table memty, I'm saying. And column 1 integer, column 2 so 2 columns, 1 table I have created. Let me try to insert the data. Insert into empty values. Okay, now if I try to select the data, select star from memory table, it is available. Okay, and what are
Right.
the files generated for this table? Memory table, you'll get two files. One is structure
Right.
file and one data file.
Okay.
Okay, so one data file is available, but this data file, it's not. I'm so sorry. I'm so sorry. You'll not get a data file because I have created a table with. I didn't give the engine. You should not get a data file there.
Hmm. You can check create statement, right?
Yeah, I just created the table. I didn't mention the engine there,
Yep.
right? Let
Yeah,
me
it
just
went
drop
to
this table.
InnoDB.
I went to InnoDB. That's why I got a data file. The drop table menti, and I'll just create the table again. Because if I'm not mentioning any engine, by default it will go into InnoDB.
Right.
Engine equal to
Memory.
memory. Okay.
Yep.
Now you can just insert the data, insert into memory. Values. Okay. Now you can see that your data is available. Select star from memory table. Now if I could just go and see now, you can see your memory table, it is having only one file,
Structure.
that is your structure file. No data file, because data file
Okay.
is a physical file again. Your data is
Now,
now available in memory. Okay.
now
Now if
since
I just
you are out of a session, it didn't drop, or you have to stop the whole thing.
stop the server. Okay, because I'm out of the session means again I need to, because I'm the root user, I'm not a normal client here, right?
Hmm.
So my session is not disconnected as of now. So as a root user, what I'm doing here, I'm just stopping. But for a normal user, if he's disconnecting from the session also, his information is lost from the memory.
Okay. So we can create another like a test user and create another test. We'll be able to see it.
Yeah. MySQL 123
Mm-hmm.
student connected. Now if I try to see, because I have shut down my MySQL server and I'm checking, so your data is lost.
Yeah. Now
Okay,
the table
this
there
is it
though.
for you. Table is available. Your
Okay.
structure of your table is available
But
because I'm able
data
to
is
see,
lost.
but data is not available there.
Got it.
Okay, so memory engine, it will have only one type of file, that is your structure file. So that is only the .frm file it has. No kind of logging, nothing is available for memory engine. You cannot perform any kind of logging. Okay, so that was your memory engine. Then next type of engine is,
CSV.
after memory engine, we are having merge engine, merge storage engine. Okay,
Hmm.
merge engine. Merge, the name itself says that you're trying to merge something, join something and take the data, read the data.
I
Okay, so
mean,
what kind of tables you are going to merge? The merge engine is a collection of identical MySAM tables. Okay, so one or two MySAM tables you are trying to join are combined, and we get a merge engine table there. The underlying tables that you're merging, that has to be only MySAM. That is the condition for merge engine.
so you cannot have two different engines to be merged.
No two different engines. Only MySAM it has to be there. Okay,
Only my
not a
only.
combination of engines, nothing. Only MySAM engine tables, only two MySAM. Like assume that I have three MySAM engine tables. These three engine tables I can just merge and have one engine, that is merge engine I can have, and these three will be your underlying tables. Okay, so we'll see that how you so when in what scenarios we can have this merge engine. Like suppose I am having a classroom in which I'm having multiple tables, like a student database, a classroom um, uh, a classroom table I want to create, but in that I'm having multiple tables under, I'm having multiple MySAM tables. Like one table is with marks, one table is with students attendance, okay, and one table is with students complete history, like how he has performed in his extracurricular activities and all
Sure.
like that. Okay, so these three tables combinedly, I can have a classroom or your academic performance. Instead of classroom, a performance table I can have. So in the
Right.
performance table, we'll be having the student marks, we'll be having the students attendance, and we'll be having the students extracurricular activities information. So if these three tables are combinedly, I'm getting into one single table, that is your performance of a student table. Okay, like that. We can
All
just
right.
merge and we can have. So let me just create tables here, like some tables are being created here. So merge engine, let me just go and create this merge engine. So create table, table name, roll number, some auto increment, roll number, it should be auto increment we are seeing, and class, character, student name, and engine equal to MySQL. So one table one tab, TABL1, I have the roll number, class, and student name. And again, I'll create one table, table2.
Could three different table.
Okay, create table, table2. Again, in that also we are having roll number, class, and student name. So multiple classes information I'm joining here. Okay,
Right.
so I can have table 3 also, but I'm taking only 2 tables here. Now insert values into these tables. First, we'll try to insert values into table 1, like class and student name I'm trying to insert.
Mm-hmm.
Roll number, it is auto increment I have given. So anyway, it will try to give some number for your roll number.
Okay.
So class and student name, like class 5 and Stephen, class 5 and Nina, some names have been inserted there. Insert values into table 2.
What do you mean two record duplicate?
Sorry, records 2. And if you have any
Oh,
duplicate records,
duplicate 0. Okay,
no,
duplicate
2
0.
records I have inserted, 2 rows are inserted. I don't have any duplicate records, no warnings
Okay,
like that.
got it, got it.
So table 2 also we have inserted certain values. So table
Mm-hmm.
1 is holding class 5 information. Table 2 is holding class 6 information. Okay.
Okay.
So these two tables I can join and I can have one bigger merge table. So which is all class. All class
Mm-hmm.
indicates like having all your from class 1 to class 10, all your class information. But here all class I'll have class 5 and class 6 information combined. Combined class 5 and class 6 information you can have in your all class table, which will be using a merge engine. So you can see the syntax here. So create table all class, it is also having roll number, class, student name, engine equal to merge. Okay, merge, if I'm using engine, then you have to mention union, like which tables you're going to merge. Okay, joining, which tables you're going to join. So I just have 2 tables here, that is table 1 and table 2. So just take these 2 tables. Insert method equal to last. Insert method last means like whatever the new records you are inserting, always in the merge table, that record should be inserted in the last. Okay, otherwise what happens if you don't give this insert method, the data might be inserted anywhere.
You
Okay,
mean
in
the
a
last
random
minute
location.
in
Like
order of
suppose I have
the
10 records.
last?
Yeah, last.
Okay.
Suppose I have 10 records, 10 rows in a table, and if I'm inserting 11th row, it should be on the 11th place only, right?
Okay, not
But if I
the
don't give
20th.
insert, yeah, if I don't give the insert method, what happens? This 11th record can be inserted randomly in any location. Like
Got it,
it can
got
go and insert as a second row or third row, whatever row it might go and choose, and it will be inserted. It should not be like that. So insert method equal to last, we say. Now what happens? I have got a merge engine. Now let me just go and select. I have merged these 2 tables, like table 1 and table 2 I have merged. Now let me select your all class table. Select star from all class.
it. Uh-huh.
your two classes tables information is merged here. That is class 5 and class 6 information is merged and it is available.
So when you do use merge, you have to have about table structure same.
Yes, yes, you're right. When you are doing the merge table structure also must be the same. Like you should be having a roll number, class, and student name.
Right.
Exactly the
You
same.
cannot have like one table has 4 columns and one table has 3 columns, something like that.
Yeah, you cannot have in that way.
Okay, got it.
And
Yeah.
that too, your merge table also should be having the same column and the same order,
Right. That's what I mean.
so that
Everything
your
has to match.
underlying tables, like so that your underlying tables data can be properly arranged in a proper order.
Right.
Okay, so what kind of files has been generated here for your merge engine? So if I just see here for your merge engine, we have generated table 1, table 2 were your MySam engine tables, right? So
Yeah.
definitely for MySam engine tables, 3 files you have got. Table
Right.
1, 3 files, table 2, 3 files. Then after that, all class was a merge engine table. So for that all class, you have got all class.frm a structure file and .mrg file. It's a merge kind of information about your merge table is available. It's not
Okay.
a structure file also. It is just like which tables it is going to merge. That's why you can see the size is very, very less.
But
Okay.
most of the data will be located in table 1 and table 2.
Table 2, you're right. So if you
Just
are
when you
inserting
do the
data,
query,
yeah, you are
it's just
going to
pulling up.
insert the data in table 1 and table 2, but you can actually see the data in all class in the merge table also.
Yeah, when you query the all table, then you get to see both table.
Yes, you're right.
Okay.
And all class.mrg, it is holding the information that how many tables it is merging.
Right.
Okay, so it is merging 2 tables here, table 1 and table 2. So basically these two are the files for your merge engine, .frm and .mrg.
Okay.
So this is for
When
your
do you use this kind of application? What purpose of that?
same thing. That's what, like here, like I have a class 1 to class 10 in a school. Okay,
Okay.
every class has an individual list. Okay, class 1 has its own student information, class 2 its own, class 3 its own. But I want to have a one final list of all your classes from
Okay.
class 1 to class 10, all classes final list of information I want to have. Okay,
Just
so
on
then
one
I can
record.
have this merge engine, all your tables, all your classes merge, and one final list we can have where all your classes information is stored in one single table.
Okay.
Okay,
Now, would
so
their
that is
performance improve or what?
uh,
Performance wise.
performance wise, like having this more reading from a smaller tables only, it will be good enough, but readability wise it is much easier. Like you want to have access to, because going and connecting to every, like suppose you are the principal of a school and you are the head of the department and you want to see how all your students has performed in each class. What you
Right.
do, you are required to go and open each and every table there. Just open your class 1 table and check the class 1 table information, class 2
Hmm.
table, class 3 table. So every time you're going and opening and closing the tables, opening, closing, it will take time there. Every table, whenever a query hits a table, okay, so the query execution time is really very important there. When a query is hitting the table, opening the table will take time, reading the data from the table will take time, and again after your queries data is read, again closing the table also will take time. But instead
Right.
of that, if I can go and hit one bigger table there, that is all class table, where I can get at a time, like on one single opening of that table, I can get all the tables, all the classes information in one single location. Okay,
Okay.
so performance wise, both advantages are there, disadvantages are there, because reading the data from a bigger table definitely will take time when compared to your smaller tables. But again, reading the data, one time it is opened, I can just read the data, whole data I can read in one go. In one shot, I can read all the data. So that
Okay,
is again the advantage. So
got it.
both are available, but mostly we cannot consider the performance here, but we can consider the time here. Like, yeah, it is much
Time
easier
consuming.
for us to read all your classes information in one single table. We are able to get all your classes information like that. Example.
Okay.
Okay, so we have got for merge engine, we have got, and it's a non-transactional support engine. All engines are non-transactional support engine. Only INODB is transaction. Okay,
Right.
non-transaction. And two types of files we have got for this one, that is .frm and .mrg, merge and structure file. So that was for your merge engine. Then we are having next is your CSV engine. CSV is comma separated values.
Okay.
CSV engine. Okay, the CSV engine stores data in text files using comma separated values and is always compiled to your MySQL server. So whatever the engines we have seen till now, INODB, MySAM, or Merge, or memory,
Memory.
any engine, when we are storing the data is stored in the form of binary files. Have
Fine.
you
Okay.
opened any data file and have you seen any data file open and have you read any data file? No.
No.
All your data, always data in your data files will be in binary format only, right?
Right.
But here CSV is one special type of engine where your data will be in your text format.
I mean,
And the text
FT.
also, it is separated with commas.
Okay.
Okay, all your columns are, sorry, all your column values are separated with a comma, and comma separated values. Your data will be in text format. So I can just go and open your CSV text file, data file, and I can read what exactly the data is available in your data files. Okay, so
Okay.
in what situations this kind of what you call engines or
Application.
tables are helpful there. So when you want to when you can actually go and read the CSV file and you can actually send it to an Excel sheet. Okay, suppose I
Okay.
want to build up an Excel sheet of some certain records like employee attendance or something is there. If a table is there where we are trying to hold your employee login and log off time and how many leaves he has taken and all. Okay, so if I can have all these data in a text format, simply just move these data from your CSV file into an Excel sheet or into an location where you can get your all your employees attendance information. So basically moving the data will be much easier if the data is in a text file in your data file, your OS level.
Okay.
Okay, it doesn't support indexing, it doesn't support your partitioning and all. Okay, so in CSV engines, your data cannot be indexed. That is one thing. And it cannot be partitioned also, the data in your CSV engine. So let me just show you how your engine will look like here. So when I'm connecting here to your server, I can just mention the database name here also. MySQL-u root-b student. If I'm saying, you will be directly connected to the student database. You
Got
no need to connect and then say use student. Okay,
I
so
got
from
it. Okay.
OS level only, I'm directly making connection to student.
You can connect to whichever
Okay,
database you want to.
database you want. Yes. So here you can see create table, color table we are creating with serial number, color name, and color code. Engine equal to CSV. Some random table, color table where
Sure.
you can store your color information, colors information. So now we'll try to
Insert data.
insert data into this table. Okay, insert into color word, color values like color serial number is 1, color name is Indian red, color code, then light coral color name, salmon color, and the color code. Like 3 records we have inserted into this table. Now if I just say select star from color, you are able to see read the information.
Mhm.
We'll just say select star from
Color.
color.
Okay.
So you can see you are able to read the table information. It looks like a normal table now, but when I
Right.
just go for a data files here on your uh, OS level, then you have three types of files here. One is structure file, that is FRM. Then we have a .csv file and .csm file. Okay, so what does
Okay.
this CSV and this CSM indicates here? So the two extensions we are having here. Okay, so your the server creates a table format file or a structure file with .frm and a data file with CSV extension. Okay,
Yes.
uh,
We have third one, CSM.
so let me open this CSV file. CSM indicates your metadata information because your data is stored here in the OS level itself. So
Uh-huh.
CSV is holding the actual data and CSM is holding the metadata
Okay.
information about your data, because at your OS level, special type of file is created here where your text data is available. Okay, so you can see your data is separated by commas. That's
Yes.
why it is comma separated values. Now suppose I have a requirement like in a table I'm having some 1 lakh records. Okay, I have a requirement that these 1 lakh records I need to send it to into a file or into Excel sheet I want to transfer. How do you do that thing generally
Hmm.
in a table if I'm having? Okay, so it's not possible. You have to dump that table. You have to take an export of the table. Generally in Oracle, how do you do? You just take an export of that table. Okay, a dump file will be there. Then
Right.
just convert that dump file into a text file. Then copy that data and do it. But here, very easily I'm able to get the text file. Now I want to move this data to some location, or I just want to insert this whole data into a different table also. So just copy all these data. It's like your SQL loader
Mm-hmm.
you have in your Oracle. SQL loader also has the text file, right? Loading
Right.
huge amounts of data. So this data I want to load into a different table or into a different file I want to move. Just copy this data and paste it over wherever you want. That's all.
Mm-hmm.
So that is the
Okay.
advantage of, again, this is a very special type of engine. Like every table I don't want to have as a CSV engine, right? So
Right.
again,
Right.
lately we try to have this type of engine also as a default engine. Okay, so again, this is also a special type of engine. So as I told you, other than InnoDB and MySam, very rarely other engines try to have as a default engines. Very rarely,
Now,
not
can
even.
you can you create a table from one engine to the another engine? Like take an InnoDB engine table and create a table in a CSV engine?
Yes, yes. Default engine is InnoDB. You are saying, right?
No, what I'm saying is like insert into the new table, select from old table, and then you specify the new engine, right? Something like that.
Mhm. Okay, you want to move the data from. Okay, you want to create a new table, but you want to read the data from an another
Other
engine table.
right, like read a table from InnoDB table and
Yes,
put it
yes,
on
you can
CSV.
perform. You can do that
Okay,
way.
okay,
You can do that way. So whatever the end table is there, your files are created with that engine. Like suppose you want to create a table as a InnoDB, and you are
right,
going to select the data from a MySam engine table.
right,
So you can use it and you can have it. And some databases you can have a combination of engine tables also. Like right now in the test environment here in your class, I'm doing a combination of engines only. Like my default engine is InnoDB,
right.
but I have a MySAM table, I have a CSV table, I have a memory table also, like a combination of tables. But
Yes,
generally, in actual environments, we don't have your combination of engine tables there.
you might
Okay,
have
which might
two
have, yeah,
mostly.
in actual environments, like if I'm choosing one as a default engine, all tables will be with that engine.
Right.
Okay,
Or you
very
might have
rarely we try to have
my
your,
same.
yeah, very rarely we try to have different type of engines in the same database, in the
Right.
same server, different types of engines.
No, this is just
Okay,
if
so
someone asks us, I need to get this data into the Excel or something, so we can do something like this, perform, taking
yes,
from
with
one
your CSV
engine to,
engine, you can do that.
then you can take
You're
that
right.
CSV file and okay, give it to them.
Yes, you're right.
Okay.
Okay. Then next is your archive engine and example storage engine, black hole engine, federated. So 4 more engines are available. So we'll see that in your next class. Okay. So we'll
Okay.
stop it over here. So today we have seen 5 types of engines. That is InnoDB, MySAM, memory, merge, and CSV engine.
Okay. Save the notepad, and once all engines are done, then you can hand me this notepad. Okay.
Non-transactional support engine, it's also, and it has 3 types of files, that is .frm,
Okay. CSM
.csm,
and CSV.
and CSV.
Yeah,
CSV is holding the actual data there.
correct.
Okay. So
Now
these are the different types of engines
yes,
we are having. Yeah.
correct. I have a question on this binary installation we done. Installed on my
Yeah.
machine, okay? But when you want to start their engine, you have to start only in a safe mode, or is there any other way you can start regular?
No, you have to start in a safe mode
That's the only way you can start this
because
database.
that's the only way it can start with your binary installation.
Okay, because I try to start.
This conference will now be recorded. This conference will now be recorded.
Okay, so last class we were seeing about some uh, storage engines. Okay, so we have seen some 4 or 5 types of storage engines last class. So today we'll be continuing from there only. That is last I think we have seen the CSV storage engine, that is your comma separated values. So
Correct.
whenever in engine that storage engine CSV engine, if you are inserting the data is actually kept in a text file. It's not in a binary file, so that you can move this text file to any other location also if you want. So that is the importance of advantage of using the storage engine. Then next is archive engine. Archive is used to store large amounts of data. Okay, large amounts of data in a very small space, like in a compressed format you want to store your data. Okay, so that in that scenario we'll use this archive engine. Like suppose I have around 100 GB of data. Okay, in a table example I'm having 10 GB or 10 GB of data I'm having in a table, and when this data is stored, it is stored in a physical file. Okay, some data file it is stored. But when this is stored in a file, it should be stored in a compressed format in around 1 GB or 2 GB space. Okay, so what is the advantage here? Maybe sometimes what happens is you might have some space issues. Okay,
Sure.
so you might have some space issue that you don't have sufficient space, but you really have a requirement that you want to go and create a table. Okay, so in
Okay.
that scenario you can simply go and create an archive engine table, so that your table will be created and your space utilization also will be very less, because 10 GB data you are actually going to store in 1 GB space only, because that data gets compressed and it is stored. And when you are trying to read the data from your database level, that data is decompressed and you can read the data also. Okay, so this type of engine is used when you have a certain kind of space issues on your disk. Okay, so storage
But
limits none. Yeah.
But the storage issue, wouldn't it be too late when you notice that the storage is filling up, and then now you to create archive engine, or you have to pre-plan it?
Actually, if you have storage space, if you want, you can increase your space and you can create a normal engine tables also you can create. But this is a special kind of engine they have given in MySQL. Like if you have very urgent requirement of creating a table, but you have very less space and you cannot go and increase the space. You
Okay,
don't have a chance actually. So in
right,
that scenario, you can create. Or if you have a chance also, but you don't want to waste your storage space. Okay,
right,
you don't want to waste your storage space, then you can actually go and create this archive engine table so that your tables are also created, but they are created in a very small space, very small footprint, like in a compressed format your tables are created.
right.
Sometimes we try to do that thing because we don't want to utilize much of the storage space there. Storage limit will be saying none because it depends upon how much of uh, what you call actual table size is there and how much it want to compress. Okay,
Okay,
so it doesn't depend upon the size, and also storage limits none they have given. Transaction and locking anyway no, because no other in a
but you don't
no
have
other
all
region
this
other,
feature though.
yeah. INODB is only the transactional support engine, so that you don't have any MVCC control also. All
Right,
your data types and indexes are supported, but some of the indexes like B-tree, tree and hash indexes, these indexes, um, cluster indexes and all these indexes are not supported. You can compress the data and you can encrypt the data because this is your compression only, so you can compress and encrypt.
right.
Replication support is also available. Point in time recovery, you can update. Updating your statistics are also possible in your data dictionary. One more
Okay,
advantage of using archive storage engine is it supports your insert and select. Generally, a non-transactional support engine means what? It only supports your select.
but
You
so
can
on this
only read the
one,
data.
so this one only insert, or you can also update and delete?
No, you can't update and delete. Only insert.
Only
Archive
insert
engine
and
does
select.
not. Yeah, archive
Oh,
engine
there
does
you. I
not
didn't see.
support your delete, replace, or update. Okay,
Okay, I didn't
so
see
there
that one.
is a, yeah, in archive engine only one more advantage you can get is like you can perform your select on this is a non-transactional support engine, right? So
Right.
select anyway you can do that, but in addition to select you can perform insert also. Insert also will be supported.
Okay, so this is kind of like if you want to archive some other table from other engine and keep it here with the low disk space, then you can use.
Yes, you are right. You're right. You can insert into that new table from another table.
And right, and then delete the other one, clean up.
You're right. You're right. You can
Okay,
do it
got it.
that way. So that
Okay,
kind of scenario, if you're having also, you can perform. You can use this archive engine and do the insert into a new
okay,
table.
right,
Okay.
right.
So order by operations are supported. Log objects, vlog objects are supported. Auto increment on a table you can have. For a column you can have. For a table column you can have your auto increment values you can have, but it can't support your delete, update and replace operation. Okay, so the archive engine uses zlib lossless data compression, so it uses this compression algorithm, zlib compression algorithm.
Okay.
Okay, so that compression algorithm it is saying rows are compressed as they are inserted. On retrieval, rows are uncompressed on demand. Okay, so by default, the rows are uncompressed or decompressed. You don't need to have any kind of decompression algorithm when reading the data. So that
You
is
don't need
one
any
more
special
advantage.
command.
Yeah. Whenever you just say select star from the table, automatically the data is decompressed, uncompressed, and you will be receiving a normal data as an end user.
You will get
Okay.
your result as normal.
Yes. So
Got
let's
it.
create this table. Anyway, we cannot see because compression means I need to have a huge amount of data and you'll see
Yes.
that the size will be decreasing there. But at least I'll just try to show you how to create your archive engine table here. Let me
Yep.
first start MySQL server. It is started. Now connect to the MySQL server -u root -b. Directly I'll connect to the student database.
Perfect.
So I'm connected to student database now. Now let me create a table here. I'll just say create table ARCH, some archive table I'm creating, and n integer, some column I have created, and I've created a table. Now try to insert this table into data, insert into archive table values. So very small kind of table, and 2 or 3 records I'm inserting here. Actually, if you want to see difference of your size of your file for archive engine, like huge amounts of data, very big table you can actually create there. So here,
Right.
let me go to varlit MySQL directory. There you can actually var. Okay. This is the location where your files are present. So go to student, and you can see there the archive engine.
2 right there. Top.
Yeah.
Yeah.
arch.frm and IPT. So 2 files are created for archive engine. One is FRM, that is your structure file, format file or structure file, and then next is your data file.
IB
So
data.
this data
Okay.
file size is showing us here this one. But if you really want to see, like if you have inserted some thousands of records, actual
Right.
size of the file should be like around 5 GB or like example 10 GB. But if you come and see the size of the file here, it will be around like 1 GB. Definitely it
Correct.
will be in a compressed format. Okay,
Sure.
so this is how we try to create an archive engine table, and it is used when you are having any kind of space issues and you don't want to utilize your space there. Okay,
Sure.
special type of engine. Then next is your example engine. The name itself says that it is an example engine. It's a sample engine. Okay, sample kind of thing. Okay, so your example engine is used as you can use this example engine to generate your own engines. Okay, so you actually have now around 7 or 8 type of engines in MySQL. Okay, only these types of engines are available. But as I told you, your MySQL code is freely available. What many of the companies they do, they try to modify your MySQL code and they try to derive their own MySQL databases like MariaDB, MongoDB, and all different types of MySQL databases have been derived, Percona and all. Okay, so in addition to the databases, you can create your own storage engines also. Okay, so that is your development people job, like they can actually try to go and generate a new type of storage engine according to your requirement. Okay, so that kind of storage engine, if you want to generate, you can use this example storage engine as your syntax, as your code. Okay, so you can use this example storage engine and you can go and develop your own type of storage engine.
Got it.
So that's why your example storage engine, it doesn't create any files, it cannot store any data into a table, it returns an empty result if you're trying to, even if you try to create a table with example storage engine, you cannot insert any data, you cannot retrieve the data, nothing, because it's just a sample engine. So it's not allowed to go and store your data and all, it cannot be indexed and all. Okay, so that is reasonable because it's just a sample engine, you cannot work with the data here. Okay,
So it does
just
not
for
store anything, really?
nothing.
Wow.
It's just a kind of template you can consider.
Okay.
It's just a template, a sample which you can use it. Okay, internally the code you have to use it. You can use this example storage engine and you can go and build up your own type of storage engine.
Okay.
Okay, so that's why they have given. Then next is your black hole storage engine. The black hole storage engine, black hole, the name itself is given there, that black hole means what? It doesn't have anything in that. Okay, so here also the black hole storage engine, it doesn't accept, it accepts the data, but whenever you try to select the data from the table, nothing will be there in the table output.
Okay.
It
So
returns
what is the
empty result.
so
Okay,
what is the
so we'll
purpose
see.
of these two engines?
Yes. See, I have a I have created a table as a black hole engine table, and we have inserted the data also. Like I have inserted some 10 records into the table, and we just left. Next,
Right.
and I just go and try to select the data, but I'm not able to read the data from your black hole engine table. So what happened to the data actually? So whatever the data I inserted, that data is actually gone to your binary logs. Okay, so special types of logs are available, binary logs. So in your next classes, I'll tell you what are these binary
Sure.
logs. So what are these what is the advantage of having this kind of storage engine there? Suppose you have a database and you are having some space issues again in your database, that you can have a table in your database, but you cannot store the data in that database. You just need to have the data in a remote server. On a different server you want to keep the data. Table
Oh,
has
okay.
to be here, but your data has to be in a different server. Okay, so
For
what we do,
different disk
we
storage.
yeah, you're right. So like your clients will be connected, like your application is running on this server. So if application is running means what, your clients are connected to this server. Okay, so by actual server, but whatever the clients or whatever the data that is being modified, that data you are not going to store in the actual server. That data has to be on a different server.
Okay.
Okay, so in that scenario what happens is whatever the data you are inserting in this black hole engine table, that data is actually taken by binary logs, and from binary logs you can move your data to that other server, whatever the different server you want to store your data.
Okay.
Okay, so this kind of engine is also used in many of the environments there, because many of the environments what happens is wherever the applications are running, those servers you don't have access to much larger storage there. Okay, and your applications are just running on that, like an application server you're having. Okay, and your application server is not holding the data database also. It's a different server where your actual data is being stored. So in that scenarios, you can have this black hole engine. Okay, so that is the advantage of having your black hole engine there. So let me just go and create a black hole engine table there. So I'll
Okay.
take it from here, create table. Just log in into your database, student database. Now create table, test 10 subtable. They are creating serial number, message, some text message or something. Engine equal to what? Black hole.
Black hole.
So my black hole engine table is created. Let me try to insert the data also. It will take the insert also, but you cannot read
Okay.
that data here again. Insert into test and values message 1, message 2, and your data is inserted. Now let me just try to select the data, select star from test, and your data got inserted and it is safe, secure, but you are not able to read the data from this table.
Right.
Okay, now the data is where in your binary logs. Okay, I
Mm.
cannot show you now the binary logs. In your binary logs class, I'll show you how to
Okay.
enable your binary logs and how to um, check the data in your binary. Actually, the binary logs means what, it's in binary format. You cannot open the logs. They're not kind of text files there.
Right. It's
Okay,
special
so the data,
characters in.
yeah, the data is in binary format only. But now definitely the data is there in your binary logs, and from binary logs you can write a code or something you can write where you can actually try to move the data from this server to another server table. In another server you can have a table, and from there you can actually go and store your data. Okay, so that is your black hole
Okay.
engine table. So what kind of files are created for your black hole engine table? So you can just check here. So I've just created a test 10 table. So you can see your test 10 table in this server,
Frame.
it is just giving only a
Metadata.
structure file, metadata,
Right.
okay, structure only, not the actual data file. So your data file also is not created here. If data file would have been created, your data would be present there, right? So only a
Yep.
structure file is created. Your actual data is there in your binary. Okay,
Okay.
so that is your black hole engine table and example of advantage of using your black hole engine. Very rarely these kind of engines are used in actual environments actually. Okay, maybe for one or two tables you might have a special requirement, then you go for this type of engines. Otherwise, as I told you, very rarely we try to go and use this type of engines.
I
Mostly
see.
we'll have an InnoDB or Python engine tables and we'll work with that in MySQL. The next is your federated engine, storage engine. The federated engine is used to access data from a remote MySQL server. Okay, this is a reverse of your black hole engine table. Okay,
Okay.
what in black hole engine, what we have done, we don't want to keep our data in our local server. We just kept our data in a remote server, right?
Right.
Locally, we are making changes to your data. We are inserting, doing, and everything locally. But those changes are not but the data is not kept in local server. The data is there in a remote server. That was your black hole. Federated, it is reverse. Like you are trying to access a data not from locally, but from a remote server. You're trying to access the data.
Okay.
Okay, like suppose a client has, like suppose that there is an company table, and in a company table you are having some employee table information you want to know. So a user has requested your local server that I want to select start from employee he has given. The table is not there locally now. Where is the table? The table is present remotely on a different server. So now, whenever the user fires a query on my local server, your federated engine actually tries to redirect the query to your remote server. From remote server, the data is read, and then the data is given back to the user. So your client, your client or user will feel that it is actually reading the data from a local server, but it is not reading from a local server. The data and table is actually present on a remote server. Okay,
When
so
you say remote server, I mean different SQL, MySQL.
different server, different
Mm,
MySQL server. You're right. Different
okay.
MySQL server. It's not a different database. It's a complete different server only.
Right.
Because
So
in
it's kind of
MySQL
like
we have
a
multiple.
database link, isn't it?
Yeah, you're right. You're right. Absolutely right. Kind of
Okay.
database linked. Okay, so it's a kind of database link only we are using here. So the different server IP address and all you have to give so that your
So
connection will be made.
okay. So it's getting from
So
different server and all the database and all that.
yes, no data is stored on your local tables. No data
Great.
is available on your local tables.
Okay.
Data is there on a different server. So how you're making the connection there? So when you're creating the table itself in your, what you're doing, you just create the table structure in your local server. When you're
Uh-huh.
creating the table, the structure is created, engine equal to federated you gave. Then you try to make the connection, like a database link you're trying to give here. So you
Okay.
need to give this connection. In connection, what is there? MySQL. You need to give the username, like a remote user you create that will be going and accessing your remote server. Fed user at the rate remote host. Port number you have to give the remote host port number, whatever the port number you have, because networking in MySQL is only through port.
Yep.
Okay, so you just need to give the network port number and where exactly under which directory the table is kept. So there is a federated directory example they have created, and under that we are having some test and underscore table, some table is created. Okay, so this
Okay.
kind of connection, this connection command, generally when we create a table we don't give any connection command or something. We just create a normal table, engine equal to federated. I would have said that's all. Okay,
Okay.
so if you say like that, what happens? Your table would be created and your data, whatever the data you stored, that would be stored in local table only. But I don't want that data to be available and to be accessible here locally. So we want to have that data, access the data from a remote server. So just have that table data from a remote server. Connection command you have to give. Okay, so practically we cannot see this federated table because I need to have another MySQL server. In that MySQL server, one more table, so that local table can go and access the data from the remote table.
Okay.
Okay, so this is kind of database link here. So this is your federated engine. So examples of, and this completes all your engines there. So
Okay.
all your engines, like out of the engines, I told you like your MySam and InnoDB are very, very important there. So many a times when you just start working with your MySQL, or if you go and attend any kind of interviews in MySQL, most of the questions are asked on your InnoDB and MySam, the features, the size limits, what kind of file system your MySam and InnoDB has, and all these things. So differences, a table is given here, so you can find the differences here. This is basically for 5.5 and 5.6, the limits. Again, for every version, these size limits will be changing. Database size limit, storage limits will be changing. So
Okay.
you are having for InnoDB it is 64 TB per table. Per table it is. Okay, so and 256 GB for MySam engine. So like this, it's a transactional support engine. It's not a non-transactional support engine. You can give this major 5 or 6 differences whenever somebody asks you differences between InnoDB and MySam. So
Sure.
InnoDB has a lesser storage limits when compared to MySam storage engine. Okay, so it has a transactional support, MySam no transactional support. InnoDB row
All right.
level lock, MySam table level locking. InnoDB MVCC control is available, like concurrently users can go and access the data, but MySam MVCC is not available. Okay, so like these your differences you can see here.
Sure. Yep.
Complete table you can just find. It's a very good table. Please try to read it so that because many times these questions is asked like how you are, what are the differences actually between them, and which is more useful. Okay,
Right.
so again, how can we decide like which is more useful? So it depends upon what kind of data your what kind of data requirement you are having. So do you have huge amounts of select? Okay, do you have huge amounts of reading, or do you want to have changes and those changes also should be affected there? Like example, I've told you like Google, lot of select will be happening. Users will
Right.
not be doing much changes there. So that environment you can have your MySam, MySQL engine. Okay,
So,
MySam engine you can have there. But when I'm using Facebook or Twitter, their users will be giving their inputs. If you are doing a post, okay, whatever the
right.
changes you're doing, those changes should be affected. What are the comments you're doing, that comments should be enabled there and it should be visible there. So that kind of databases you should be having it support for changes also. There you can use your InnoDB
And
engine.
InnoDB. So Google, how about the Gmail? Wouldn't that part of the InnoDB or the MySam?
Gmail also, I think it's a MySam only because as an end user, okay, you are connecting, okay, but
So you are writing an email,
mostly
you compose it.
don't know, maybe internally what kind of we need to check there. Okay, Google pages, Google search pages are MySam engine only. Search pages, search engine kind of
Right.
thing. So
Google
for
search, but
Gmail and all the
email has to be under other.
other engine might be because
Yeah.
it's just a reading, or you want to make the changes and they have to be permanent, might be InnoDB.
Hmm.
Okay, so that was your storage engines, very, very important. So please try to read your theory book, PDF book that I have shared, because that is actually having all the uh,
Sure.
engines information there.
Yep.
Okay, so now next we'll see. Uh, Suppose I just wanted some MySQL administration. We'll see. So whenever we try to install your RPM installation for MySQL. So we just know
Hmm.
one directory, that is valid MySQL. This is your default directory created. But in addition to valid MySQL, you have got some other directories also created where some more information is available. Like your USR bin location, some client programs and scripts are written. Scripts are available in USR bin location. Okay, and USRS bin location, your MySQL server will be running. Your MySQL server information you can see. Varlib
Okay.
MySQL actual log files and databases information you can see. This we actually know. USR shared location manual your manual info format, your MySQL manuals, readme books that will
Okay.
be available there. Okay. So like these, you have some kind of directories. So in addition to valid MySQL directory, these directories are also created when your MySQL is installed using RPM is installed with your RPM installation. Okay, so these are the different directories you can go and check, and I can just stop your MySQL with the etc init.d command also, start and stop. Generally I'm doing as a service, right?
Right.
But I can do with your etc init.d command, etc init.d MySQL d start or MySQL d stop. This command also I can use it, because the init.d means what? It's an initialization file. Okay, so as a
Okay.
service your MySQL is running, you can actually have this service. Whenever you are having your services, you can start and stop with your initial files also. Initialization files also you can start and stop. So that is one more option available. If you want, you can use these commands for starting and stopping, but mostly we'll try to use as a service MySQL to start and stop. And suppose I just want to read my MySQL's version. Generally MySQL version, if I log in into your MySQL server, I can just see there MySQL 123. Whenever I connect to your MySQL server, you can see there what version I'm using there. Okay,
Right.
but I'm not able to connect to your MySQL server there. Okay, I'm just an OS user, but I want to know what version of MySQL version you're running there. Okay, so from your OS level, how to know? So you can just say MySQL hyphen your root hyphen p hyphen e, select version. So let us select.
Unexpected. Double quote. Select version.
Okay, so from your OS level, you are able to see that what version of MySQL you are using. That is 5.6.29.
Yep.
So this is very advantageous also, like how you are going to go and select your MySQL information there. And not only that, any information about to know about your variables and all, like how many variables I'm having. MySQL hyphen root hyphen v student, not student. Like a normal server, I'm logging in. Okay, so how many variables I'm having? Variables are nothing but your parameters that you're there in your MySQL server. So today we'll see how to
Okay.
do your parameter settings. Okay, so show variables are variable settings and parameter settings. You can see how many variables and parameters you are having in MySQL, around 452. Okay, so
Wow.
around 452 parameters you are having in MySQL. So many parameters and some default values are already given. Okay, so you can see version comment. What kind of version you are using? Version is also a parameter. Okay, so
Okay.
you can get your version as 5.6.29 version comment. So what kind of version you are using? You are actually using a MySQL community server
Community version.
with GPL license. Okay, so that kind of version, and what your version compiled machine. So on what it is acceptable, the platform. So we are using a 64-bit platform here.
80.
Okay, so like these lot of parameters are available, like for you can see so many parameters are there, but I cannot scroll all these parameter, and I just wanted to read one single parameter. So in MySQL there is a whenever you are selecting for parameters, you can do your wild search, like wildcard search you can do, and you
Okay.
can read your parameters. Parameters are variables information. Okay,
But we're gonna
so
go
how
over
many
with the
suppose I just
important
want
parameter, right?
exact parameter, if you know, then you can just give the exact parameter name. Okay,
You know
but
what I'm
if you
saying?
don't know the exact parameter,
What I'm saying, we are gonna go over the some important parameter, important
yes,
whatever the configuration and whatever that.
yes. important parameter, and we are going to see here like what parameters we are having. Like any parameter you want to know, you can just use this command here like this. Show
Sure.
variables like
Okay.
yeah, show command will give you the parameters. You can go and read these parameters. Like example, I just want to know show variables like percentile. uh, I just wanted to read the information about INODB. Okay, I
Okay.
don't know. I just have INODB. I know. I wanted to see what are the different parameters or variables related to your INODB. Just give INODB. That's all. You can see 121 parameters are related only for INODB.
Wow.
Lot of parameters are there for out of 452 something, 121 are there only for INODB. So INODB, lot of parameters for INODB.
30% is look like
INODB
a
buffer
INODB.
pool, INODB buffer pool size. Today we'll be seeing these buffer pools also. Buffer
Okay.
pool is nothing but your cache. Buffer
Sure.
is nothing but your cache memory. Like these, you are having lot of parameters here. INODB file per table. We have seen there like INODB file per table. If it is on, that's why you're getting every table is getting one file, one individual file you're getting there.
If
Okay,
it's
earlier
off, it will be
this
right. If it's off, it will be only
yeah,
one file for whole database.
one file. You're right. We're right. And you can see INODB data file path. Actually, data file path, it first goes to your IB data one, which is 12 MB by default, but it is auto extended. You can see the
Okay.
parameter value there. Okay, so the INODB data file path is metadata or actual data is first gone into your IB data, then it is transferred to your actual data is stored in your normal data files. But because this is auto extended, you don't need to worry about the size and all. But even though it was auto extended, the size was growing in huge size, like very huge files we were getting in earlier versions. Because of that, from 5.6 onwards, we just stick to metadata in IP data one, and the actual data will be stored in different data files.
Got it.
Okay, so these are the different parameters. Actually, a lot of parameters are there which we never see on a daily basis, but there are certain parameters which we'll be covering here. Okay, so like these, I can just go and read any kind of parameter I want to know. Like suppose I just want to see show variables, like I just wanted to know what port number it is using, percentile, port, percentile. I don't know what is my parameter for your port. Okay, so just say
Okay.
percentile, port, percentile. And you can see what kind of port. Okay, port is having your parameter as port only. So what is the default port number it is using? 3306. I have not mentioned anywhere at the time of installation or after installation also what kind of network port number I'll be using. Okay,
Right.
but by default MySQL has a port number as a 3306. So a lot of default values are available. So you can
Okay.
actually go and read those values by using this command, show variables command. Okay, so this is your variable settings. Now next is your types of caches in MySQL. Caches are nothing but today we are going to see memory components in MySQL. Caches in MySQL server. Memory components. Next class we'll be seeing logs in MySQL, different types of logs. You remember in your MySQL architecture, we were seeing there that whenever a query comes in, first your query goes to your connection manager, thread manager, and a parser will take the query. It will parse the query and generate a passcode, and then it gives to your optimizer or different component modules like
Yep.
that. But when the output is given back, a copy of that output was kept in your MySQL query cache. Okay,
Okay.
so that was only one cache it was showing. But when we are working with different engines, actually different types of caches are available. So that we'll be seeing, like we are just extending the architecture today. Like we are going to see how many different types of memory components are available for your MySQL server.
Okay.
So caches in MySQL. The first type of cache is your INODB buffer pool. So for INODB, you have a separate cache here. So in this information, you can read it from your PDF book that I have shared with you. The
Okay.
PDF theory book. So types of buffers in MySQL server. The first is your key buffer or key cache. So this is for MySAM actually. So the first type of cache is key buffer. Key buffer you can say, or key cache. Okay, so this is related to your MySAM
My SAM
intent
engine.
tables. MySAM tables. Okay, so for MySAM tables, you will be having these key buffer or key cache. So this is a special type of cache available. The MySAM engine exploits a strategy. So it employs a cache mechanism to keep the most frequently accessed tables blocks in your memory. Okay, so what are the tables that are most frequently accessed? Okay, those
Right.
tables are output you can have in this type of special cache, that is your key cache or key buffer. Like in Oracle, do you have an idea? Like this is not your database buffer cache. Okay, so in database buffer cache, what happens? Whatever the transactions you are doing, whatever the output you are getting, each and every output is kept in your database buffer cache in Oracle, right? So here
Right.
also, your in MySQL also, we have a kind of database buffer cache, that is your MySQL query cache. We'll see it later on. The MySQL query cache will have the actual output there. But in addition to that, in Oracle, do you know that we have keep cache and recycle bin cache?
And
Okay, so
Oracle,
your keep cache will be in Oracle
yeah,
databases. Yes. In addition
keep,
to database buffer cache, we are having some key cache and recycle cache.
yes,
Okay. So what is your keep cache? Keep cache will be holding your frequently accessed tables.
right.
Okay, special type of cache. Same way here in MySQL also we are having, for every type of engine you are having a special type of cache. Okay, keep cache in Oracle will try to hold smaller and frequently accessed tables. The
Sure.
frequently accessed tables and smaller tables you can have in keep cache, and larger and less frequently accessed tables you can have in recycle cache, like that. Same way here also in MySQL also we are having like frequently accessed MySAM engine tables. You can keep it in a very special cache. Special cache your MySQL will try to keep the data, that is your key cache or key buffer. Okay, so here what happens here again when you're storing for index blocks, a special structure called key cache or key buffer is maintained. For data blocks, MySQL uses no special cache. So what is this again? So here generally we know that in your buffer caches your data blocks are only stored normal cache whenever we are trying to access a data. Okay, so in normal cache we just know that whenever user tries to access the data, user tries to access the data blocks, and a block images, your block prints or blocks images are available in your buffer cache, so that next time the same query is coming in, the same data blocks can be read, right? But
Right.
here again a very special key is that your MySAM key cache or key buffer, it is not storing your data blocks information in your key cache. What it is storing them? It is just storing your index blocks information. Okay, so why here index blocks? Okay, because in MySAM, as I told you, like a lot of reading happens. Okay, a lot of select happens.
Select
So to
queries.
have faster, yeah, to have your faster access to your data, so much of indexing is available for your MySAM. And you
Okay.
remember MySAM engine tables, you have separate index files also.
Correct.
Okay, so again, this is some kind of special thing in MySQL. Like in Oracle, you never see any index file for Oracle. Okay, so index files are not available there for Oracle databases. But in MySAM engine, you are having a separate data file, a separate index file, index for index storing, okay, and then a structure file you'll be having. So whenever you are trying to have this key cache or key buffer, it will not hold that data blocks, but it will hold that index blocks that are there in your index file. So that whenever a user fires a query, okay, for your MySAM engine table, first your indexes. Anyway, your MySAM will be using these indexes only for going and accessing your actual data. Okay, Okay, so because your indexes are hit first, that's why it is practical that if you can store your index blocks in your key cache, that will be having more access to your data, faster access to your data
Yeah,
it can give.
faster access.
Yes, so that's why what they are doing in key cache or key buffer, they try to store your index blocks information so that same query is coming for the second time, then then your MySQL server will actually go and try to read your index blocks from your key cache, and then it will try to go and read your these index blocks, whatever the data blocks it was pointing, that they will go and read it again. An IO is required there, but that IO, 2 times IO is not required there, because indexes are also a separate file here in MySam. At least
Yep.
your index blocks IO is not required there. Okay, many of them have a query like anyway for data blocks I have to go and do an IO and read the data from your file only, from your
Right.
table only, from your disk only. So what is the advantage here? The advantage you are having here, you are having faster access to your data, but not completely. Like
Mm-hmm.
they would have stored your data blocks also in your there, that would be beneficial, but data blocks are not present there. Okay, so just an index blocks are present. So because it's a separate file also, so you are avoiding one IO there. Okay, so
Mm.
index blocks are there, they'll go to the
Yep.
file, they'll go to the disk, read your data, and then give it back to the user. This kind of have keeping your separate cache for your MySQL actually improves your performance a lot. Okay, it will
Okay.
improve the performance of your a lot. You can
So
actually
that mean
disable this cache also. Yeah.
that mean you have to have more memory so at the server level in order to keep have your buffer,
No,
keep
no,
buffers.
more memory is not required actually, because we are just keeping your index blocks information. We are not keeping your data blocks information
Oh,
here.
just the index block.
Index blocks. So index blocks, indexes doesn't require much amount of memory, right?
Correct.
So it's just an information about index blocks. So your MySam key cache doesn't require more memory there.
Oh, okay. So
Like
it's
if you are storing
if
your
it is
data blocks information, it would require some memory there.
okay. So it goes to read the index block and then index block will go get the data block.
Data, yeah, data block that is available on your disk. Very fastly it happens because you are directly going and hitting the indexes. From indexes, whatever the linked data blocks were there, that will be read and it will be given back to the user.
Okay.
Okay, so if your data blocks were present in your MySQL cache, then that would be a problem there, because first, whenever your MySam ingest tables are read, they are read through your indexes only. First, if data blocks were present in your cache there, your user would have to go and first do an IO and then read your index blocks. Then that particular index connection data blocks are there in your cache, then read your, that would not make any sense there, right?
Right.
So
So then too
reading it,
much
too much of time it would take, but because first it has to go for your index blocks, going and reading on your disk index blocks,
and
then
you cannot
coming and
fit
reading your
everything.
data blocks. Yeah, so that would take more time there. So well, because of that, a different type of cache, because till now we didn't see anywhere that your indexes blocks also can be stored in your cache. So this is a special type of cache for storing your index blocks information of your MySam. So how can I know that what kind of how much of size it has given for your MySQL key cache? Okay, so let me just go and see the for MySQL key cache. To control the size of the key cache, use the key buffer size parameter. This is
Key
your
buffer
variable
underscore
that you
size.
need to use. Key
Okay.
buffer size, key underscore buffer underscore size. So let me just see this parameter here.
So how would you size this?
Yes. So actually, whenever we try to install your MySQL server, depending upon your memory of your server, some
Mhm.
default values are automatically picked up.
Okay.
Okay, but if you feel that no, I just want to go and resize this one, so in your you need to shut down the server, because these are the memory parameters, they are static parameters. So shut down the server, go and change your parameter value in a configuration file and then restart it.
So these are not dynamic parameter. They can
No,
change it on
You
the
can
fly.
have certain parameters as dynamic also in MySQL. We'll see in your next class what are the different dynamic and static parameters you can have.
Okay.
So you
Yeah.
can change your parameter value dynamically, or that dynamically here in MySQL is called as globally. So you can change it
Global
globally,
parameter.
or you can change it in a static way also, like you need to shut down your server and go there.
Okay.
Okay, so two options are available, but most of the memory parameters are your static parameters only, because you're changing the memory component means what, like your server level changing you are doing. So definitely you need to shut down and you have to make the change in your configuration file only, like in P file in Oracle.
Right. Right.
Okay, so show variables like percentile, what is that? Key buffer cache. Okay, so
Key
I don't know the
underscore
exact
buffer
name, so like I'll just say key buffer
size.
percentile.
Okay. Yep.
Okay, so you can see now you're having a key buffer size which is of around 8 MB. So
8 MB.
yeah, it's around 8 MB. Yeah, 8 MB size only they have given, because what is my server memory size here, around 2 GB. Okay, so this is my server of around 2 GB. Out of that 2 GB, they have just given around 8 MB for your key cache or key buffer. Okay, so why 8 MB? Because it is just storing your index blocks. Index blocks doesn't require more amount of memory. So very small amount of memory is allocated. This is a default setting that your MySQL server has done at the time of installation. I have not given this setting, right? So this is some default value, but if you feel that no, this size is very less, you can just go and modify this value also.
Okay.
Okay, but generally for a key cache and key buffer, we don't try to modify the value depending upon your memory. Like suppose if you are working on a 16 GB server or
Mm-hmm.
something, so depending upon that memory, some random value will be picked up and it will be given to your key buffer there.
So we don't
Okay,
change
so
key
for your
buffer by
MySQL, generally we don't
recommendation.
change, but if you feel that yeah, it's not changeable, it's not changed, actually these values are not changed, but if you feel that you want to change, you are having an option. You can go
Okay.
and change in your configuration file. You
But
can
it's
make the
not
change.
recommended to change this.
Yes, it's not recommended to change. Yeah, it's not recommended to change, because whatever the value that they have given, that is an optimum value based on your memory. An optimum value is picked up according to your MySAM engine size and tables and all. An optimum value is picked up, so that is more than enough. So you
Okay.
might have a doubt, like 8 MB is a very small size, right? How can it can store, like suppose I'm having a 200 TB table. Okay,
Right.
so I might have a very huge tables, and is that index blocks are also kept like in 8 MB? How can it be storing that much of index blocks there?
If
8
you have
MB is a
more
very
than
small
8 MB
size.
of index, then
Yeah,
you cannot store.
index blocks are there. We cannot store there. So what should we do there? So
Right.
actually here also they are using this um, what do you call the um last in.
Temporary.
Yeah. So but that is your most frequently accessed blocks are kept on top of that. Okay, least
Right.
frequently.
MLSU and MSU.
Yeah. Yes, you're right. Least frequently used tables will be there on top of the blocks will be there on top. If you're not using them frequently, then they are flushed out onto your disk there.
Yeah,
Okay,
but
so
for example, let's say you have 8 MB 8 MB and you are firing up a new query that's more, the index size is more, let's say more, okay, more than 8 MB,
then the
like a
query
10
will
MB.
fill. Then yeah, generally it will not be having it that way, but if
Right.
suppose if you are having more size, then your query will definitely fail there, that it cannot read. Fail in the sense it will take more time basically.
It
It
will
will
be
not fail
performance
also.
issue will be impacted.
Yeah, performance issue, you're right. It will not fail actually, but it would take more time, and you can see that your query is taking more time to access. Then you can go and see in your performance reports there that your key buffer size was not sufficient, so
Right.
it
Then
went
you have
and
to
read
tune
directly on your disk.
this parameter.
Tune this parameter, you're right. Tune
Okay.
this
Got it.
parameter. But most of the time, like more parameters, more index blocks, if you want to keep that the least frequently accessed
Right.
LMS, that kind of it actually use that kind of thing, that LMS and all
Algorithm.
list LRU list will be there. least
Sure.
recently used list will be there, and based on that it will be moving your blocks there. Okay, so this is for your MySAM engine tables, that is your key buffer or key cache, special type
So that
of caching.
okay. So there's
Then
only one memory parameter in the MySAM.
yes, for MySAM, actually, yeah, only for MySAM engine tables, only one MySAM, like one parameter, key buffer or
Only
key
key.
cache.
Okay. So only one parameter for MySAM.
One parameter. Okay. Next is for InnoDB. For InnoDB, and again another parameter. For InnoDB, we are having a buffer caching. Call it as InnoDB buffer caching.
Mm-hmm.
This is specially for only for InnoDB tables.
Right.
Especially for InnoDB tables. So what kind of parameter things will be there? In InnoDB buffer tables, you are going to keep your data blocks only. Okay, you're not going to have your index blocks or something, because in InnoDB, your index blocks and data blocks, both of them are there in one single file, that is your data file. Okay,
Right.
so your data blocks are only kept here in your InnoDB there, and it also uses your LRU algorithm for restoring your data. Like how the LRU algorithm will work when 3/8 of your buffer pool is filled. Okay, so then your data blocks are flushed out onto your disk and all. So basically we'll be using this InnoDB buffer pool when you have huge amounts of InnoDB tables data that is coming in, and frequently accessed InnoDB tables are there. Instead of keeping in your MySQL query cache, you can actually have the tables kept in your InnoDB buffer cache. Special type of buffer caching. Again, LRU list only, based on LRU list only it is used. So you have a parameter called as InnoDB buffer pool size, which actually gives you the size of your InnoDB buffer pool size. So you can check here, show
Variable like
variables like
buffer.
percentile InnoDB buffer. Okay, if I say buffer also, I have got lot of values here, so you can see what is
Right.
the value. InnoDB buffer pool instances, you can, sorry, buffer pool size, it is of around 1.3 GB.
1.3
Okay, the size
megabyte
is around,
GB.
yeah, 1.3 GB.
Right.
Okay, 1.3 GB, around 1300 MB or something, you can just consider. Okay,
Right.
so what is this size 1.3 GB here? Like what is my server's memory size? It is 2 GB.
2 GB.
Out of 2 GB, like 1.3 GB is there for your InnoDB only, and the remaining 700 MB that is there for other memory components. Like why they have given like 1.3 GB there. So 1.3 GB is like what, 70 to 80% of your memory we have allocated for InnoDB only.
Right.
Okay, so generally whenever your InnoDB is the default memory, default engine, when InnoDB is a default engine, and when you have a like in 5.6, InnoDB is a default engine, right? So whenever your InnoDB is when you're installing the server with a default engine as InnoDB, 70 to 80% of your memory is allocated for your InnoDB engine only.
Okay.
This is a rule. Okay, so that now I have InnoDB as my default engine, so that your 1.3 GB is allocated for InnoDB engine only. The remaining memory, like around 700 MB, out of that 8 MB is given for your MySQL buffer cache or key cache, and remaining memory around the 600 plus MB memory, that will be given for your MySQL query cache or any other memory components if you are having, that will be given to that. Okay, so this is a rule that it will be having your InnoDB will be having more size. Again, why more size? Because your InnoDB is actually will be storing your data blocks here, not your index blocks, and data blocks really require more amount of memory there. Okay.
Right.
So in InnoDB here there is something called as old blocks um, and young blocks. Okay, old blocks and young blocks means nothing but is your old blocks means that they are not frequently accessed. Okay, those blocks just flush out. They are regarded as your dirty blocks, and you can flush out those blocks onto your server, onto your disk. And young blocks means new blocks, frequently accessed blocks, and they can be actually kept in your uh, on
Memory.
top of your on bottom of your LRU list. On bottom of your LRU list, you'll be having your young blocks. So that in explanation is only given here. If you read, you can understand there that your young blocks will be there on bottom, older blocks will be there on top. So older blocks you can flush out, younger blocks very rarely you flush out, like that. Okay.
Okay.
So some parameters also given, like INODB old blocks time, old blocks, like how much of time you can have these older blocks in your what you call INODB buffer.
Kept.
Okay, housing is actually in seconds, so you can actually give some time also, like for how much of time based on your LRU list or based on your time also you can mention
So what
them,
is
like
the
how much of
okay?
time you can.
So what is the default parameter right now? Can you go to your
You can just check here. Yeah.
Yeah, what is it right now? Is there in there? No, time is not
INODB
there.
old blocks time.
NOTP old block.
Show variables like
Okay.
so old blocks time, it is by default 1000 only. It is in seconds. So
1000
1000
seconds.
seconds. Yeah, it is in
Okay.
seconds only the time. So this much of time is your given by default. So if you want, you can change this time. Okay, so
Okay.
you can make it to 0. Like you can just make it set global INODB old block time as 0.
Is it 0 mean disable
Okay,
in MySQL?
yeah, we are going to disable this. Yeah. 0 means we are just trying to reduce, make it disable in the sense like, suppose what is this old blocks time? Like if you are having your data, frequently accessed data, not
Right.
frequently accessed data in your LRU list, some 1000 seconds it is giving a grace time to be there in your old blocks. But if I'm
Right.
making it as 0, so immediately if you have any data blocks that are not frequently accessed, immediately they are flushed out onto your disk, like
Flush
that.
out. Okay.
So that kind of access you want to have, or you want to keep some grace time there for
Right.
them to be there in the in your
1000
LRU list
seconds or
there.
whatever.
Okay, so that is your that. Then last is your MySQL query cache. This is your actual